Welcome to Programming Knowledge. Today I'm going to talk about Arduino basic concept. To know what is Arduino, what Arduino can do, why and who can use the Arduino board. First, I will introduce you to Arduino kit. This is Arduino board. We can call it the Arduino kit. The Arduino has a microcontroller on it. We can call it a microcontroller kit. This is a microcontroller, and I will talk about microcontroller chips, pins, clock, and some device on this board in the next video. Okay, we will know what Arduino can do. That's easy get data from peripheral devices. We can use Arduino board to get the data signals from sensor, motor, and other objects. Moreover, it can link with peripheral devices such as USB, keyboard, camera, GPS, so on. And this is more extension board. We can call it a Arduino cells. This is devices can plug into the Arduino pin because each board has a pin extension to correspond with the Arduino. Example, this is Arduino Ethernet cells. We can use it to communicate with the Ethernet. The extend board can help you create some project like this. This is a game. We can control Arduino to play game brick, and the other I can use to control LED to create a definite mirror. And this is a hand robotic. This is Arduino. Or we can create a robot, a sonar robot. Or some popular projects create IoT systems to make our cities smarter, and many big projects out there waiting me to develop them. Okay, Arduino is an extremely easy programming kit supported by a whole community around the world. This is a logo of a community. It's open source, and so we won't have trouble when programming with Arduino. All big and small projects have detailed instruction library, so code is pretty easily and clearly to understand and read. We can search anything about Arduino on Google. And last, we will sum up. In summary, Arduino is quite small but extremely powerful, right? It can control anything in the fastest way, and many extend board help you create a big or small project. We can use it to practice, study, or develop many useful projects for people. Besides that, we are hard to stock when use Arduino to make a project because we are supported by a whole community all around the world. They always there to help you, and Arduino is suitable for all age, for all class. Example, you can be an engineer but you don't have knowledge about electric or anything about program, but you can create a Arduino project. The other is ladies. The old men can use it to develop some healthcare project to help them better. And especially, kids can use it to study, research, and create many creative projects. We can find by Arduino kit easily in our city. So don't hesitate to start with Arduino board. Thank you. We have two parts in this video. First is microcontroller and pins, and the second is clock and power. Okay, let's start with the first session. This is the pin diagram of the Arduino Uno, and also is the pin diagram of the ATmega328 microcontroller. I will talk about the ATmega first. This is ATmega belong AVR series, has 28 pins. You can see in the picture it has 3 ports right here. First is port B, the second is port D, and port C. Um, On-OR port can be used to input or output the data signal. Each port has the different pins function such as PWM pin, SPI pin, I2C pin, or UART pin, and some power pin right here, GND and VCC to supply power for chip. Next, I will talk about the Arduino board. Arduino board are developed from 80MHz 328 microcontroller. Arduino Nano and Arduino Mini also use this microcontroller on board, and they renamed own pins for easily call. Example, they mark 0 to 7 for block D, 8 to 13 for block B, and A0 to A5 for block C. Each of these pins doesn't change its function. It still has function like PWM, UART, I2C, or SBI. I will talk in the next video for each function. But only the PWM, they mark a title right here. You can see the title is marked for PWM pin. As I said, all Arduino pins can receive input and send output digital signals. Pins from 0 to 13 are digital pins that can be received digital signal level 0 or 1. You can call it low or high signal. Pin A0 to A5 are analog pins. This pin can still a digital pin because it still receive the digital signal or output the digital signal, but they usually use this pin for analog. Okay, this pin used for receive voltage signal and convert it to the decimal, usually called ADC or analog to digital convert. And some other pins right here, 3V3, 5V, GND, and VIN right here to supply the voltage. It have a reset right here to reset the board, or you can press the button reset right here for convenience. Okay, next is the clock and power. Clock on Arduino, we can use external or internal crystal, but there is a 16,000 MHz crystal on the board, so we use the clock signal from around 16,000 MHz. The ATmega 328 has both the external and internal too. Okay, next is power. We can supply power for Arduino board via power jack right here. We can supply it from 5 to 12 voltage, but it should be less than 12 voltage because it may be hot when supplying power for a while. Or we can supply 5 volt via USB jack right here. It is a USB jack type B. Or we can supply via VIN pin right here from 5 to 12 voltage. On the board, there's some power less right here. UART signal LED and some other electronic components to help the board operate stably. So that's all about the board and the microcontroller of the board. Supply power, clock, and pins. You can find out it on the Google, or you can search about each function in the datasheet, and I will talk about the function in the next video. Okay, thank you. Welcome to Programming Knowledge. Today I'm going to talk about how to install the Arduino IDE and how to upload the first sketch into the Arduino board. Okay, let's start. We'll search on Google by this keyword, Arduino download old version, because there some old version is more stable than the newer version. Okay, shut it. There are many old versions right here, and the newer version is 1.8.8, but the version 1.8.6 is more stable than the other, and we'll use this 8.6 in this video. There are two options for downloading. First is Windows installer, and the second is Windows. I will talk about this. The installer packet here, the installer package will be installed on your computer system with an exe file or execute file. This way is quite hard to uninstall the library or hard to reinstall the Arduino application. But the second way, that is Windows package. That is a zip file. You only need to extract it after download it and run it immediately. I recommend you use this package because it's easy to delete and re-extract when Arduino application is error. We just need delete the old file and extract it again. So I will download the Windows package in this video. Click it and just download and save it in your computer system, but I've already downloaded. Here I downloaded, and this is a zip file. You have to extract it. Okay, then you get a folder like this after extracted the zip file. Now I will open the Arduino IDE. Okay, this is Arduino interface, and this is a text editor. You can code right here. Put your setup code and put your main code right here. And this is the output pane. The output pane will show the code compilation and some information about Arduino board after upload the code. I will introduce you some Arduino menus button right here. The first, the check mark button to verify or compile the code. The arrow key button is uploading the code to Arduino board. Next is creating a new project. The upward arrow button is opening an existing Arduino project. And the last one is saving the current project to your computer. The button appearing on the top right corner is a serial monitor. The serial monitor will actually help you debug the code via UART. Your Arduino board should be connected to your computer by USB cable in order to activate the serial monitor. I will use this in the UART video. Okay, this is board information in the sketch. And I will introduce you some session right here. The first is file, and in this file we have a sample. You can find more sample right here. I will open one. This is a plain project. You can use this to upload to your board. Okay, we'll close it. Next is sketch session. In sketch session, you can use the command here instead of button. Combine, upload using programmer. You don't need to use this session. And export combined binary. This session will help you create a hex file. And this session include library. You can add more zip file about library to your project by this, and or you can include some library to your project. I will click one here. It will appear a library in your project. Okay, this is tool session. We can change the relevant board we are using, and we can add more board to the Arduino like this. We can download more board in this board manager. Okay, or we can identify which Arduino board is connected to computer by COM board. We can find COM board in device manager. Yeah, right here, device manager. I will make an example later. And we can also use Arduino board as a board programmer to upload code for the others microcontroller or the other board. And the last is burn bootloader. It is very helpful to burn the code directly into the microcontroller ATmega328 or the other, setting you free from buying the external burner to burn the required code. When you buy the new Arduino board, the bootloader is already installed inside the microcontroller ATmega328. But however, if you intend to buy a new to repair and put on the Arduino board, you need to burn the bootloader again inside the controller by going to the tool section and select this session. Select burn bootloader. Okay, that is some information about Arduino application. Now I will upload an example code to Arduino. I will use the Blink example project for easy. Here, Blink project. Okay, open it. Okay, now I will connect my Arduino to the computer. As you see, the Arduino is executed the default code. We will check the COM port in Device Manager. In this session port, my Arduino is using COM3. Okay, remember that. Now we have 3 steps to upload code. First, check the board with your board. Check the board session with your board. Check the board with your board. Okay. Last, verify to check an error syntax. Okay, done compiling, and now we can upload code to the board. Upload. Okay, you see in the board, it's still playing as the default code, so we have to change some variable right here. Change 1000 to 100 for see clearly. Okay, upload. You need to verify because the code is correctly. Okay, you see the LED is blinking faster. Okay, that's all about this video. Now we can know how to install the Arduino IDE and how to upload the code to the Arduino. Thank you. Welcome to Programming Knowledge. Today I'm going to talk about how to build a simplest circuit and how to control it with Arduino. It's important for you to learn the basics before moving on, and one of the most important basics is how to use a breadboard. Okay, let's go. This is a breadboard which helps you practice and test a circuit. Okay, look at the yellow box. This is the number of columns marked from 1 to 30, and this is the column above and this is the column below. They are different from each other. And the pink box, this is the letter from A to J, and each row, row 1, row A, row B, row C, row D, row E, row F, row G, row H, row I, row G are different from the other. And I forgot, the column 1 are different from 2, from 3, from 4. They are different. I separate the board into 2 parts, part X and part Y. Part X include row F to J and part Y include A to E. 2 parts are independent together, so there are not any holes are connected between 2 parts. Okay, the holes in part X are not connected with the holes in part Y, but both X and Y are pretty similar. I will explain part X. In part X, just how in a column, do you see how 1, how 2, how 3, how 4, how 5, just 5 holes are connected together in a column, but they not connected with the column 2. The 2 columns are independent, and the other also like that. Okay, just in a column they are connected together. The part Y is also same the X. Okay, that's it about the column, but the rows are independent together. They are not connected together. Okay, they independent with each other. Okay. About the green box, they usually call those holes are rails. All holes in a rows are connected together. You see, the blue holes are connected together and the red holes are connected together. But in a column, they are not connected together. Okay, they usually use red holes for VCC power and the blue for GND ground. Okay, the rail on top right here is SMS with the rails in the green box. Okay, that's the only thing about breadboard. Now we will make a simple circuit and connect with Arduino. Okay, this is our first circuit. We have a LED and a power supply voltage right here. All of them are connected together. In real life, if you want to operate a DC device, DC means direct current. We need to supply voltage like this. The positive power will be connected to the anode of device, and the negative power will be connected to the cathode of device. Then connected all of them to the ground. GND. Connect like this circuit, your LED can be light, but please pay attention. Don't connect in contrast like this. Don't rotate the LED, because your circuit may be burned or explosive. It's very dangerous when using a high voltage supply. So remember that, don't rotate the LED like this. Some power supply has a high current, high ampere, so that can be burn your LED if you don't reduce current flow. I'll use a resistor right here to do that. The resistor will protect your device from burn where the current is higher than the current of LED. So we need to select our appropriate resistor value by this formula right here. This is Ohm law. I is U divide R. Okay, and how can we know which variable are appropriate with the resistor? So I assume like this. The current min is 10, the current max is 25, and let only light if the current min is lower than the current of the circuit and lower than the current max. Okay, but pay attention, if the current of place is greater than the current of place max, your circuit will be burned or explosive. Okay, we'll try to calculate the variable of resistor. Okay, we have min is 10 milliampere. It also is 0.01 ampere, and max is 25 milliampere. Also is 0.025 ampere. Okay, at the formula right like this, we have min lower than LED, lower than max, and LED right here. LED right here is the formula. Okay, min, we will replace the variable to the min is U divide resistor, and max is 0.025. Okay, next we will find the resistor. We'll find the resistor, but the U is 5 volt. Okay, just one variable, we can find out the resistor like this. 1001. When we change the position of a fraction to each other, we have to change the side. Okay, now we can find out the R by U 0.01 greater than or U 0.025. Okay, now we can find out U is 5 volt and divide 0.01 is 500. U is 5 divide 0.025 is 200. Okay, this is a variable of resistor. Okay, and the variable of resistor can be greater than 200, but it should be lower than 500. Okay, the resistor can be from 200 to 500 ohm, But in this video I use the 330 ohm for easy buy in the electric store. Okay, now we'll use the Arduino as a voltage supply and connect like this diagram. I will connect the 5-volt pin of Arduino to the resistor and then connect to the anode pin of the LED. The GND pin of Arduino is connected to the cathode pin of the LED. But how can we know which pin is cathode and which pin is anode of the LED? So look at the picture. Is normally the longer LED is anode and the shorter LED is cathode. Okay, remember that. And then we will supply the voltage for Arduino and see what happened. Watch the video. I will use the red wire for 5 voltage. Connect to the resistor. I will use the black wire for GND. Okay, connect to the LED. So now I will connect my Arduino to the laptop. So see what happened. Okay, the LED is turned on. Okay, now we will write a program to control it. So now we will program for Arduino to control it. So I will change some pin right here. I will change the 5-volt pin to the pin 8 of Arduino. Okay, I will change the pin 5-volt to pin 8. Okay, and now we have a shortcut like this. The first line is I define my LED is pin 8. I define on is 100. I comment right here, LED will on in 100 millisecond, and I define off is 200. The LED will be off in 200 millisecond. Okay, in the set of function, I will put a line like this. Pin mod my LED output. This will set my LED as output pin. It means set the pin 8 as output. Okay, in the function loop, I have some line right here. The first is I will output the pin A with 5 voltage, and I will with this line I will output my LED with 0 voltage. Okay, and between them I will turn on LED, keep turn on, turn off, and keep turn off, then loop again. Okay, I will upload the code to the Arduino and see what happened. This is my code. First, check the board, check the COM. Okay, verified. Okay, now we'll upload the code. Okay, as you see, the LED is blinked. Yeah, the LED is blink like what you want. You can change some variable here to the blink LED, faster or slower. Okay, now I will change to 1000 and then I upload to the Arduino. As you see, it's blink slower. Okay, that's the only thing. And okay, you can try some practice right here. First example, you change GND pin to one of digital pin. It means you should connect the GND pin to one of digital pin. I explain which pin is digital in the second video. Or you can change both GND and VCC to digital pin. Digital pin is pin from 0 to 13 or pin A0 to A6. Okay, try it. Or you can connect more or less and make it blink from left to right, right to left. Okay, I make wrong like right here. From center to left or right, and on blink in at the same time. Okay, you can connect more or less to do what you want. Thank you. Welcome to Programming Knowledge. Today I'm going to talk about syntax in Arduino and do some exercises in order to get used to with Arduino. First, talk about embedded system. We have to know about binary, aka logic level. Okay, here binary is the smallest unit of data in computer with single value, either 0 or 1. By these digits, we can commute with microcontroller or almost hardware. And in our video series, we will define logic 0 is low level and logic 1 is high level. Its equivalent 0 is 0 voltage when we make an output, and 1 is 5 voltage. Okay? And about programming language, the Arduino compiler accepts C and C++. In fact, many of the open source libraries are written in C++. Much of the underlying system is not object-oriented, but it could be. Thus, the Arduino language is C++ or C. Okay, you can use C or C++. Therefore, we also have syntax, variable, and data types, etc. as the other programming language. But with embedded system, we have some new data types because system can sometimes define integer to be 8 bits, 16 bits, or 30 bits long. This is some new data types. That is, byte is equivalent on size char, and the size is 8 bits. And next is unit unsigned in 8 is equivalent unsigned char. It has 8 bits size, and more is 16 bits and 32 bits. Okay, now I will talk about Arduino function in IDEA Arduino. Okay, in IDEA Arduino, when we create a new project, there are two default functions will be appear right here. You see, setup function and loop function. Pay attention, we don't have main function in this IDEA like the other IDEA to code. We just have two functions like this. Both of two functions you void right here. It means in this default function we don't need to return any variable, but when you create your function, user function, right, you can put any data type as you want to handle your project. I will make this sample later. Okay, in setup function we usually set up some function to start, and we will run program in loop function. Yeah, right here, declare init call function, set up some pins, etc. once time. It just run once time. It just run once in setup and then it out. But in the loop function, your program will be repeatedly. Okay, your program run forever inside loop function until you disconnect the power of Arduino, because we don't need a device run continuously. Because we need a device run continuously whole time to check sensor, check weather, check LED button, etc. That's the reason why we have a loop function. We don't need a device run once and then off forever. Okay, understand? This is how we organize global, local variables, and user function. So in the head of text editor, we often include some libraries, and then we also define some variables below that. And next is global variables. You can define global variables here to use in whole of your program. And next is user function, but you need to put your user function above of setup function to avoid errors. Okay, pay attention about that. And the last one is if you want to create a local variable, you need to init in a certain function you want. This is a sample. Local variable in setup function cannot use in loop function. Okay, if you want to use local variables, you need to init in a certain function. Okay. Okay, that's the only thing we need to know when start with Arduino. Now, first I will explain about Blink project again, and then I will fix some exercise in previous video right here. Okay, let's check Blink project. Okay, here this is Blink project. I will delete some comment right here for easy, for clearly. Okay, they set up pin mod in setup function and write a algorithm in the loop function right here with this line pin mod let built-in and output. So what is that? This line means we set up pin let built-in, and let built-in of Arduino is pin 13. Okay, pin 13, and output right here means we will set up it as output pin. Okay, we can change this line to here. Okay, we will set up it as output by this line. Next, in loop function, we also change for easy. Okay, first line is mean make an output voltage at pin 13, and the output voltage is high. Okay, is high. It means we will output 5 voltage at pin 13. Do you remember high level? Yes, it will make an output in 5 voltage. It will make the LED on. And next, the LED keep on in 1 second. Then this line will make the LED off because they use low. It means the pin 13 will output as 0 voltage. Okay, turn off the LED. Then they keep turn off the LED in 1 second and repeat forever. Okay, do you understand? We just use 2 lines in this exercise. First is pin mod, and the second is digital write. Pin mod will set up your pins with status is output, and the digital write will make an output with high or low. Okay. Okay, that's it about the Blink project. Now I will make a second task. Here I will make this because the first task is asymmetric with the second task, so I don't fix the first task. Okay, let's start with the second task. In the previous video, I have the diagram like this. Now I will change a little bit of cathode pin of LED. I don't use GND pin anymore, but instead of that, I will use pin 7 instead of GND to control LED like this. I have a diagram like this. Okay, here I have already written the code for second task, so I will explain the code before I make a circuit. Okay, so first I will define a variable with name is my anode LED is pin 8, and I define my cathode LED is pin 7. It's clear in diagram, right? It's clear in diagram. Pin 8 is anode and pin 7 is cathode. Okay, right here it's just a variable, so I define like this for easy change number of pin if you want. Okay, next I define a variable LED on off is 1000. Okay. Okay, next I have a setup and loop function right here. First, and I said if you want to use more pin, right here I use pin 8 and pin 7. We need to init pin 8 and pin 7 as output right here. Pin mod pin 8 as output and pin mod pin 7 as output too. Okay, next I will run this line once because this cathode LED I make an output is low voltage. It means I will output 0 voltage at pin 7 is equivalent with GND, so I don't need to put this line in the loop function because it's like a GND. So in Blink project, do you remember in Blink project they just use only one line to control it. Okay, right here I have digital right anode. My anode LED is mean I will make an output at 5 voltage in at pin 8, and then keep turn on, turn off, and keep turn off. Okay, now we'll connect my circuit and upload to Arduino for clearly. Here I will connect anode pin to pin 8 and connect cathode pin to pin 7. Okay, then we'll connect to the laptop. Now I will check the COM board. Is it COM3? Okay, then is my code. Okay, I will upload to my Arduino. Okay, it's uploading. You see it's blink. Okay, it's blinked. Okay, we will go to the next task. That is finally task. We will connect more LED. We'll connect more LED and make it blink. We can make it blink from left to right, right to left, from center, or anything you want. You just need to control it to practice for better. Okay, and I have a diagram like this. I will connect GND to cathode of LED for easy, because I want to control 2 pins at the same time. I just want to control 1 pin is anode. Okay, the anode of LED 1 I will connect to pin 10, the second to the pin 9, and last is pin 8. Okay, right here, pin 10, pin 9, and pin 8. Okay, now I will make a circuit like that. I will disconnect my Arduino first, and then connect like a diagram. Okay, I have okay, first a resistor. I will plug like the diagram first. Second and last one. Okay, then we'll connect LED with anode is here. Suddenly right here, lastly like this. Okay, and then we'll connect the anode first. The anode will connect on the left, will connect to the 10, a 9, 10. Next a 9 in the center, and the last one is 8. Okay, 8. And the cathode LED will connect to the GND. We will connect to the GND. I will connect right here. Connect the cathode of center pin. Center LED is in one column. Right here, and then I will connect it to the GND. Okay, connect to the GND. Okay, we'll connect like this. Okay, now I have a program. have program for last project. I also define like that. Anode let 1 is 10, let 2 is 9, and 3 8 like the diagram. Then I will let on off. I will define let on off with 500 millisecond, and then set up init 1 by 1. Okay, init 1 by 1 as I said. Then I have a loop function like this. First I will turn on the LED turn on LED 1, then keep turn on LED 2, keep turn on LED 3, keep turn on, and then I will turn off LED 1, keep turn off LED 2, keep turn off LED 3, keep turn off. Okay, now I will demo for you. Connect to the laptop, check COM bar, and then upload. You see the magic. See, the LED will blink from left to right. Okay, with these light you can control your LED from left to right, but you can also change it to control from right to left, or from the center to the left, or from center to the right. Okay, the code is so easy, right? It just have pin mode and digital right. With turn on left, you just have digital right with high, and turn up with digital right with low. Just to light, you can control your LED. Okay, right now I will create a user function. Void and my function. Okay, my function is, but as I said, we have to put it above the setup function. In this my code, and in the loop I will call the my function like this. But this way you can call my function multiple times without using many code. Just call this function and the program will blink the LED. Welcome to Program Knowledge. Today I'm going to talk about serial port and serial monitor on Arduino. In the previous videos, we have already know how to write the program to control LED. Now, besides just blinking, it would be nice to provide some information directly to the user by display on computer screen. We can do this by working with the serial port and the serial monitor. Okay, first we will talk about serial port. That's an asynchronous port on the computer, transmit or receive data 1 bit at a time. It's one of the oldest types of interfaces was commonly used to connect printers and external modem to a PC. The serial port standard is RS232. It's quite slow because it's just transfer data 1 bit at a time. Quite slow, but nowadays almost devices use USB to transfer data because it's faster than RS232. And we also have a USB port on Arduino, and that's a Type P board, which we're supplying voltage and uploading code. So the data will transfer by this port to the computer. Okay, next about the serial monitor. As I introduced, we have a button on the top right corner of Arduino IDE. That's a serial monitor, and someone called it is terminal, so I also call it a terminal in this video. The terminal is a separate pop-up windows that acts as a separate terminal that communicates by receiving and sending serial data. data can be sent in both directions. It means you can transfer or receive data at the same time. Because the terminal is using UART protocol to transfer data between the computer and Arduino, and UART is a full duplex protocol. You can search on Google what is UART and what is full duplex protocol. UART is a universal asynchronous receiver transmitter. The serial monitor is very useful. It's not only displayed for fun, but we also use to debug. Okay, as you know, in embedded system, we can use breakpoint to run step by step as the other software on some idea. But with the Arduino, we can do it. We can debug step by step, and we can do the other way is check by let. Example, if you want to check a line of code whether run or not, you will call a function turn let on above it. And if your let is on after run your program, that means your code is executed. Okay, do you understand? You will put a function will turn let on above your code you want to check, and then you run the program. If your let is on, that means your code is executed. Okay, those are some ways to debug. But with Arduino, the best way to debug is print out some string to terminal. Okay, we will use this terminal to print some information to check the code is executed or not. Okay, now I will make an example on Blink project. Okay, we'll open a new project and then open a Blink project in the example session here. Okay, we'll clear some command for easily see. This is the serial monitor button, and we'll try to click on it. Okay, there's an error. Oh, why? Do you know why? Because I cannot open the serial monitor if I don't connect my Arduino to the computer. So if you want to open the terminal, you have to connect the Arduino to computer first. Then you can open the serial monitor. Okay, we'll connect it to the computer, connect my Arduino. Okay, I have just connected. Then you open it. Okay, this is the terminal windows. You can see it. Okay, now just let it there. So now I will set up some function to open the serial port on Arduino and set up to send some information via serial monitor. And in Blink project, I also use LED button. Also is LED 13 for easy, because I want to connect LED to the circuit. I want to use LED on the Arduino board for convenient. So first, to turn on the serial port, we will use this function serial.begin 9600. Okay, this line of code tells the Arduino to turn the serial port on. So remember, put this line if you want to use the serial port. Serial.begin, and this is a number. So the 9600 tells the Arduino to communicate at 9600 baud. This baud is the speed rate of UART protocol, and you can change it to the other, but there are some default values such as 9600, 2400, 4800, 115200, etc. I will show you in the terminal later. And why we have this number? Because if you put the higher number, you can have a faster speed of data transmit. Okay, the higher rate, the higher baud rate, the faster speed of data transmit. And the important thing is you need to make sure your Arduino and your terminal is set to the same baud. Okay, in this project I will use 9600 because in the terminal right here, in the terminal I also use here 9600, and this is some baud rate you can change for faster or slower. Okay, I will set the same baud between terminal and in code. So we only need run this function once. So I will put it in the setup function. I don't set up in the loop function. Okay, remember that. I will comment for you. Remember. Okay. Next, to print out something on the terminal, we will use this function 0.print bracket. In this bracket, you can use quotes to print a string, or with a variable you don't need to type quotes right here. Okay, in a string I will put a string hello, this is my blank project. My LED will be turned on after 3, 2, 1. Okay, let's check. Verify. And then upload to the Arduino here. Okay, I will open the terminal window for you see. Okay, the terminal will put hello, this is my blank project. My LED will be turned on after 3, 2, 1. Okay, and then your Arduino is blinking, but it's fast, so you can see what happened. So I will make it slower for you, easy to see. Okay, here I will put a delay here. Serial.print 3, 2, 1. Okay, and between them I will put a delay for easy sees. Delay, and here delay. Okay, this is the old string, so now I will upload the new code and see what happened. Hello, 3, 2, 1, and then my LED is blinking. Okay, you see. Okay, that's a print, and I will make an example if you want to change the different baud rate. I will set the baud rate on terminal is 1150200 here. You can see anything, but your string still print out, but you can't see anything right here. Okay, I will change it to here. Oh, you see, you cannot understand what are those symbols, right? That is some special characters. That is the reason why we have to set the same baud rate between two devices. Okay. Right now, in 9600. Okay, you see, this will be display on just one line. So if you want to the code is beautiful, what I have to do? So this is the way to do that. Okay, let's check. I will put a character is new line right here. Print. Okay, and copy it to here, copy to here. Okay, I will run again. Three, two, one. Okay, that is beautiful now. So, but this way maybe not good for developer and it's quite consume memory. Instead of you can change it by this function. This is the best way for if you want to make a code beautiful and shorter by put the ln. It means the line new you will create a new line each time the Arduino bring the string out. Okay, right here, and you can delete this line. Okay, run. You see the magic. Yeah, the code is very clearly right. Okay, now I will make an example with a variable, and we'll set up a local, a global variable right here, and we'll put the name integer, and name is count on, and assign it is 0. And I also have a count of 0 here. Okay, this means after I turn on or turn off LED, I will increase this variable by 1 and then print out to the terminal how many times I turn on and how many times I turn off LED. Okay, I will put a function 0 dot print LED on, and then 0 dot print count on plus plus. Okay, with the LED off I also do like that, LED off and LED off. Okay, space for easy see clearly, upload and see the result. On 0, off 0, on 1, off 1. Sorry, I forgot to here. Okay, let's check in. One, 2, 2. Okay, that's a it's loop forever. Okay, it will count each time the LED on and each time the LED up. Okay, I will make an example about debug code to know if your code is run or not. Okay, we'll delete it for easy. Delete it. This too. Okay, now I have a loop for in I is 0 to 12. I have a loop inquiry from 0 to 12, and we'll check it if the eyes is even. I will turn on the LED, right? Okay, if we don't have the terminal, we usually use this way, but now I have a terminal. I use this way and bring the terminal for a user now to check if your code is running. I will 0 print this event. and I will bring the index, and this is art. Okay, let's check. Oh, I forgot here. If your I is even, your program will run into the if condition, but if that is the odd number, it will run into the else if function. Okay, as you see. Okay, that are some things about serial port on Arduino. You can bring anything you want to the terminal, or you can debug, or you can check by the terminal. Okay, there are many functions about this topic, but I can list out here. You can look up on Google. Welcome to Programming Knowledge. Today I'm going to talk about loop and about string, which I used in the previous video. Let's go. First, with the loop, we have two command loop types that we often use in Arduino. The for loop, which I used in the previous video, and the while loop. I will explain how the for loop works first and make an example. Then I will make an example with while loop. Okay, this is the procedure and how to create a for loop. In the for loop, we have four parts. First, initialize loop variables. This means you have to create a begin value. And the second is check condition expression. This means you have to check condition with the end value in order to continue loop or exit. And the third, you execute the statement. It means you run the program in loop and then you update variables. This means you will increase or decrease your value you create. Okay, and the for loop is corresponding to for position. This is the loop syntax. First, you have to put the initialize here. The second is condition, and your program run in the bracket. And the last one is update your variable. Okay, now I will make an example and explain. I have a blank project right here. Okay, and I will make an example right here. Put right here. Now, for example, the for loop I have 4. I will init the variable. I will in j is 0. This means the loop will start from 0, and then if the condition is j less than 3, and update the variable, I will increase it by 1, and then I have a program right here. I will bring something to the serial monitor. Again, this means the for loop will initialize the variable j is 0, then check the condition. If the condition less than 3, your program will be executed. But if it's greater than or is 3, will be out the loop. Okay, and then it will increase variable 1. And instead of initialize like this, we can initialize the variable out of the loop like this, and you just put change right here. Two way, you can put outside or. Okay, now I will run step by step for you now. First, when j is 0, j less than 3, right? Okay, it's less than, so the program will execute print 0. to serial, and then increase the J1, J plus plus, and now J is 2, it is 1, right? Okay, now when J is 1, J less than 3, right? Now the program will execute and sprint 1 to serial, and then J increase 1. Now J is 2, and now when J is 2, J less than 3, right? It will print 2 to 0, and then J plus plus. J now is 3, and it will check when J is 3. J cannot less than 3, right? J cannot less than 3. The program not execute, and then it will out of the loop. Out loop. Okay, that is the program. It will run like this. Okay, now we will compare to the result on serial monitor. Okay, now I will connect my Arduino. Don't care about this and about this. Don't care it, because I just write a program in this and check this. Okay, now board, board file. Okay, now I will open the serial port by this function 115200. Okay, now I will upload the code and check. Oh, this serial port of serial monitor E9600. I will change it. Okay, then we'll change the baud rate to 115200. Here, it will print 0 to 1 2, right? Print 0 1 2 like I said. Okay. Okay, then I will use loop to control less again. I have a diagram like this. Previous video like this. Here the diagram will connect pin 10 to left, pin 9 to left mid, and the last one is 8 to the right. Okay, now we're playing left to right or right to left by loops. Okay, now we'll open Blink again. As I said, in the previous video, you have to initialize pin mod one by one with pins you use, but cannot use many setup line. So that's the reason why I have a loop. We have a for loop. Okay, I will use this loop here from 8 J from 8 to 11, because it will if I put the 10 right here, it cannot reach to 10, because it will come back to 10 and out. So I will put 11 right here. 11 right here. Okay, and we'll put this function to the loop. Okay, now I can set up the I forgot, I will pass the J right here. Okay, now I can set up the pin mod 8, 9, and 10. Now I will turn on left from left to right or right to left. I have a loop. In left, I will here. I will digital right here. I will transfer J here, J here. It will turn on left from left to right. Okay, now I will upload the code. Let's see. Oh, sorry, this card is playing from right to left, not left to right, sorry. Okay, so next I will use two new functions, that's the continue and break. So I will talk about continue first. The function continue is that it will ignore the program when you use this function. So I will make an example. I will turn on left, right, and left, but don't turn on left bit. Okay, let's see my continue function. Here I will make a condition if J is left mid is 9, and if J is 9, I will make a continue. It means when j is 9, the continue is executed and it will out of loop, and then it will increase the chase by 1, but it don't run this code. Okay, let's see. I will upload to my Arduino. It will ignore the mid LED, right? Blink from right to left, but ignore LED mid. Okay, so next is break function. This function will exit the loop immediately and it don't run loop anymore, but it exit the loop immediately. Let's see. I will make a break right here and upload the code. It don't turn on LED left. It just turn on left, LED right. Okay, it just turn on LED right, and then increase chase by 1, and then if j is 9, it's break and out the loop. Okay, that two function is continue and break. We are usually use when use loop. Now we will move to the while loop. Okay, while loop. Actually, while loop it is similar to the for loop, but it's slightly different from the syntax. It also have 4 parts as for loop. First, initialize loop variable, but it's different from this. You have to we must initialize this variable outside the loop. If not, your program may be error. Okay, and next is check condition, execute and update variable. Okay, it's corresponding to for position like this. We must initialize begin variable right here, and then we have a while loop. In while we have a condition, run program after compare with the condition and then update the variable. Okay, I will reuse the sample above. Okay, now I will change a little bit this code to while. I also have init j is 0 3 0, then while j less than 3, I will print out j. Okay, let's see. It's SMS the for, right? Oh, sorry, I forgot to update the variable. If you don't update the variable, your program may be overload because it's run many times. It lives forever. Okay. Okay, it also have 3 value like the for loop. Okay, now we will use while to make blink LED. I will change it to pin mode output, and this is 8, this is 11. Okay, and then this and will it's also have break and continue, but I don't use. You can try to use it to see what's different between them. Okay, while j less than 11. Okay, then blink, but now I want blink it from left to right, so I will change it to 11, and this is greater than 7. This is 10. Okay, now I will change minus to decrease the variable. Okay, let's check. Okay, it blinked from left to right. Okay, so now I will move to the next section, that is string. I will clear clear all of this. Okay, now in the previous video I used string, but now we'll introduce you some applications about string. When you use this function, you usually put a string in this string, your string. But now we transfer a string parameters to this function by this. I have a string, my welcome string is welcome to programming knowledge. Okay, then I will pass it to this without the quotes. Okay, let's check. It also is executed. Okay, and now if I want to combine two or more string, what I have to do? So I will do like this. I also have a string. My start string is let's go. If we are lazy, we can combine two string by this side is plus my start string. Okay, and then combine. Okay, you see, welcome to programming knowledge. Let's go. So instead of that, we usually combine string for clearly, right? Combine is my welcome string combine with a space and then combine with my start string, or combine with a new line for easily see. Okay, now I will transfer, I will put the combine to this and then upload. Okay, welcome to programming knowledge. Why is print twice? Because I forgot to clear the old code, right? Again, I will reset. Yes, welcome to programming knowledge. Let's go. Okay, well, that's a few things about loop and string. Thank you for watching the video. Welcome to programming knowledge. We've already know how to make an output and Blinklet on Arduino, but today I'm going to talk about input on Arduino. We can do many things with this. Okay, let's go. There are two types of input, that's external and internal. But first I will talk about pull up or down resistor first. It's been we use a resistor to make an input by external. And when I use these types, I will set up like this in Arduino: pin mode, pin and input. The first parameter is the Arduino's pin, which I want to receive input signal, and the second is set that pin is input as external resistor. Okay. I have a diagram like this. I will connect VCC with 5 voltage. And normally the resistor right here is 4700 ohm. The VCC will be connected to the one pin of resistor, and the other pin of resistor is connected to a pin of button, and the other pin of button will be connected to ground GND. And you see the branch right here will connect to the input of Arduino. Now pay attention of the button right here. When the button is not pressed, the Arduino input pin will receive a high level input signal. Okay, let's say this is all the way high level input. When we press the button, the Arduino's input pins will receive a low level input. Okay, let's pay attention with the button not press and this is press. Okay, the status is different from each other. Okay, this is the real circuit, and I will connect 5 voltage to the resistor and then connect resistor to button. You can use the button with 2 pins because I don't have button 2 pins in this diagram. You can connect like this. Okay, this is the circuit. I will connect 5 voltage to the resistor, then connect to the Arduino's pin input. Okay, and connect to the button at the same time. And the other pins of button will be connected to the GND ground like this. Okay, now I will make an example with pull-up resistor. I have a diagram like this. I use the diagram as the previous slide, and I will use pin 3 to receive the input signal and use pin 13. Pin 13 is mean, okay, the condition is if I press the button and after I release it, the LED will blink once. I have a new project here with name is input project. Okay, now we'll set up the pin on Arduino with an output. I will set pin mod, and the output is pin 13, so I will make 13 is input, and then I make the input pins like this diagram. That's a pin 3. So I will make pin 3 is input like this, pin mod 3 input. This means make external up, pull up or down resistor. Okay, now make a condition. The condition is when I press the button and after I release it, the LED will blink once or twice or many times. So I will have a if condition, and in this bracket I have a condition to check the input at that pin. I have a digital read, and the parameter right here is the pin you want to check, and I want to check pin 3. Okay, and the status right here is logic 1 or logic 0. The logic 1 is high level and the logic 0 is low level, as I said. Okay, now we'll check the 0 because like the reverse slide, when I press this is low level input, so I will check the low level. If the Arduino pin is receive low level signal, I will blink the LED. Okay, check if my Arduino input pin is low level. It means 0, right? And right here I have a while loop, Y digital read 3 semicolon. I will put a while loop right here to check if I still press button. Okay, if I still press the button, the while loop will loop forever until I release the button. Okay, and then after I release, check if I still press the button, and if I release after release will blink. I have a blink right here, digital right 13 output, high, and then delay 1 second, then digital right 13 low, delay 1 second. Okay, now I will copy and paste to make twice blink. Okay, instead of using 4700 kilo ohm, I don't have it, so I will use 1000 ohm. Okay, and the button, I will use the button 2 pin instead of 4 pins like the diagram. Okay, it's quite same. So now I will connect like the diagram. The diagram like right here. I will connect the red wire to the 5 voltage right here, and next is the resistor connect with 5 voltage The other pin of resistor will connect to the button, and at the same time I will connect it to the input pin, that is 3, 0, 1, 2, 3. And the other pin of button will be connected to GND. Okay, your circuit will be like this. Okay, now we'll upload the code. Check. Okay, COM3 upload. Let's check. When I press the button, the LED will blink twice. Let's check. 1, 2, twice. Okay, and now when I press, but if I still press, the LED will not blink. After I release it, the LED will be blink. Okay, release, blink. Okay. Okay. Now I will move to the pull down resistor. The diagram is pretty same with the pull up. We just change the position of resistor and button together. Right here. Change the position of button and resistor. I will connect the 5 voltage to the button and the button to the resistor and resistor to ground GND, and the branch right here will transfer a low level input. Okay, the Arduino will receive a low level input when I don't press the button, and when I press the button, the status right here is high level input. Okay, pay attention to that. This case is reversed with the pull up, right? And this is the diagram of pull down resistor. 5 voltage to the button and the other pin of button to resistor. At the same time connect to the input pin, and the other pin of resistor is connected to GND. I don't make an example with the pull down resistor because it's quite same with the pull up resistor. So you can try this pull down yourself to see the difference from pull up. Okay. Now we will move to the internal resistor. In Arduino, we will set up like this. Here, pin mode. The first parameter is still pin, and the second parameter is input pull up. When you set up like this, the Arduino will understand you make an input with these pins and you use internal resistor. Okay, this is the diagram is quite neatly, right? Just 2 wire, and we don't need external resistor. We just need to connect a button, one button pins to GND and the other button pin to input. And pay attention, when we don't press the button, the Arduino's input pin is high. It's always high. It's always high input when I don't press the button. But when I press the button, the Arduino will receive low level. Okay, now check the example with this type. I will connect like this on the Arduino. First, I will change a little bit of code. I will set up right here is pull up, and this will make internal resistor. Internal. Right here, still be like that. Check if Arduino input pin is low level, and check if I still press the button, and it's still like that. Before upload the code, I will connect like the diagram. Okay. Okay, we'll connect like the diagram. I have ground to GND, and the other pins I will connect to the input pin, that is pin 3. Okay, pin 3, and I will release the resistor. Okay, just 2 pin Okay, now we'll upload the code. Upload. Okay, now check the operation. When I press, and if I still press, it doesn't blink, but when it releases, it will blink twice. Okay, it's blinked twice. Okay, try it again with press and release immediately. Okay. Okay, that's the only thing about input on Arduino. So you can make an input with the other device instead of using button. Thank you. Welcome to Programming Knowledge. Today I'm going to talk about analog input on Arduino. Okay, let's go. First, we have to know what is an analog and what can it do. Okay, the analog signal is a continuous signal. The analog signal graph is sine, cosine, or any up and down curve like this. And this graph is representation for the analog signal in the physically. And this is a representation for the digital signal. Okay, so but in the real, when we collect the analog signal, it isn't simple or smooth like this, but the signal always noise when we collect like this. Okay, this is the analog in the real life when we collect it. And the application of this video is you can turn LED on or off when you control the potentiometer. Okay, or anything can transfer analog. Okay, and the analog is quite noisy and it's very hard to save or process. So that is the reason why we have the digital signal. The digital signal only is high or low level like this. Therefore, the analog signal will be converted to the digital signal in order to easily process and saving. Okay, we already know what is the analog signal, and now we will know how to collect it from the peripheral devices by Arduino. On Arduino, you know we have 6 pins to receive the analog signal. That's it, from pin A0 to A5 right here on the left side of and the Arduino's analog system has 10 bits. It means it can be converted the analog signal to digital from 0 to 1023, corresponding to 0 to 5 voltage. Okay, it means when you input a voltage signal in this range from 0 to 5 voltage, the Arduino will convert it to a number from 0 to 1023. It is a decimal. Now we'll test the Arduino analog system, and before we do it, we have to calculate the analog value when we transfer input from 0 to 5 voltage to the Arduino. Okay, we will calculate it, and I will use the voltage divider to create a voltage signal. Here, this is the voltage divider. I have 2 resistors. The first is Z1 and the second is Z2. The Z1 is connected to V-in and the other one is connected to ground. And between of Z1 and Z2 is the V-out. When you connect like this, you can collect the V-out with the voltage you want if you change the value of 2 resistors. Okay, this is the formula to calculate the V-out. The V-out is Z2 divide Z1 plus Z2, and all of them is multiplied with V-in. Okay, and I assume that Z1 is 1000 ohm. Sorry, I forgot to put unit here. And the Z2 is 1000 ohm. The V-in is 5 voltage. And when we apply this formula, we can get the V-out is 2.5 voltage. Okay, next is the calculate analog resolution. The resolution is the 10 bits value we will get. Okay, Okay, here is the formula to calculate. The ADC right here means the analog to digital convert. Okay, and digital output right here means the value we want to get. The digital output is 2 power n multiplied with analog input voltage. The analog input voltage is the V out in the reverse slide, and all of them is divided to reference voltage. The reference voltage of Arduino is 5 voltage, okay? And the n is the number of bits in ADC converter. The n right here is 10 bits. And I have a script right here. The V out is 2.5 voltage. And the n is 10 bits. Reference voltage is 5 voltage. Summarize the value like this. Okay, I will calculate. I will put the 2 power 10, then multiply with 2.5, and then divide to 5 is 512. Okay, that's it, 512. Okay, when we input the 2.5 voltage to the Arduino, we can get 512. We have a function to read analog value. We will use analog read to read the value from the V-in, and the pin right here is the analog pins. Okay, this is a diagram. We have a 1000 ohm and 1000 ohm right here. I will connect 5 voltage to above resistor and GND to the below resistor, and between them I will take the signal to the A0 pins. Okay, before connect, I will call it. To set up the analog pin, we don't have to set pin mode input like the reverse slide. We just need analog read pin. Here I will use pin A0. Okay, but if you want to bring the value to the serial monitor, we have to set up like this: serial.begin. This is the baud rate 9600, and then I have to bring this value to the serial by this function serial.print, and ln right here is it will bring the value to new line right here. Okay, and I will delay it 1 second. After 1 second, it will print the value once. Okay, now I will connect the circuit. I have a 2 resistor 1000 ohm right here. Okay, I will plug it right this. First, second like this. Okay, like the diagram. Okay, and the red wire I will use for 5 voltage. 5 voltage. And the black wire I'll use for GND. GND. And the green wire I'll use for the input. I will plug to the A0 pin. Okay, A0 pin. Now I will upload the code to Arduino and let's check. I will connect my Arduino to the laptop. Okay, now upload the code and open the serial monitor. Okay. Okay, you can see the value is 5. 5 is quite noisy, right? Sometimes it can be lower than the 512. Okay, is approximate. Okay, I have another sample. I will change the below resistor to 10,000 ohm and then calculate to 4.54 voltage, and the value I can get is 931. Okay, you can try it yourself to check Okay, so through this tool sample, you can apply it to control your LED. Okay, it means if your analog value is lower than 600, you will turn on LED, and if your analog value is higher than 900, you will turn on LED or turn off LED. You can control it like this. Now I have a new sample. Right here, I will use a potentiometer to control LED. If my value is higher or lower than the value, I will turn on or turn off the LED. Okay, I will connect the potentiometer like this. The potentiometer, you can use 1 kilo ohm, 10 kilo ohm, or anything you want. Okay, now we'll go to control LED via potentiometer. First, I will config LED 13 is output, and then check the analog value. If the analog value at pin A0 lower than 500, I will turn off the LED. Low. And else if the analog A0 is higher than 900, I will turn on the LED. Okay, and the other, if the analog value from 500 to 900, I will blink the LED. Okay, I have a bracket here. Okay, now I will bring H value to 0 monitor to easy check here. Here I will serial.print up. Here is on, and copy this to here. Copy both of this here. Okay, blink. Okay, if the analog value is lower than 500, we will turn off the LED. If higher than 900, we will turn on the LED. And if the value from 500 to 900, I will blink the LED, and we'll bring the value to the serial monitor. Okay, now we'll connect like the diagram. I will let it here, and I have a potentiometer is 1000 kilo ohm, and I have 3 pins. The left is 1, the mid is 2, and the last one is 3. Okay, now I will connect the 1 is to 5 voltage, the mid is 2 analog input pins, and the last one is to ground. Okay, I'll use the red wire for 5 voltage. 5 voltage. And the black for ground. Okay, and the last one to A0 pin here. Okay, and you can see it. Okay, now upload the code and check. Okay, upload and check. I will open the serial monitor to check it. Okay, now I will turn to left. The LED on continuously, and the value is higher than 900. It will turn on the LED. And now I will pull to right. Is lower than 500, so it will off the LED. Okay, the LED here is the TX, is not a 13. Okay, and now I will pull it to the between 500 and 900. Here the value is 663, 667 is between 500 and 900, so it will blink the LED. Okay, the analog input is easy, right? Some next video maybe I will read analog signal from photosensitive module, gas module, and infrared module, or etc. Okay, thank you. Welcome to Program Knowledge. In the previous video, we have already known how to read an analog signal from some basic devices. Today, I'm going to talk about how to read analog signal from some popular peripheral devices. Okay, let's go. In this video, I will make an example with 3 devices. First is photosensitive resistance sensor, gas module, and microphone. We can use this microphone for tip, but I don't have it right here, so I will use the microphone this instead. This is a product from Adafruit and it's more stable, but it's expensive. Okay, all of these devices also have digital pins, but in this video I make about analog, so I just only use analog pins in this video, and all of them have analog pins A0, A out, and AC. Okay, that's the analog pin of each devices. Okay, first I will review a little bit. This is 6 pins to read analog on Arduino, and in this video I just use A0 pins to read analog signal. Okay, first is photosensitive. I have a diagram like this. We don't care about the potentiometer because it just affects to digital signal. Okay, I have VCC is connected to the 5 voltage, GND to GND, and the analog pins of devices is connected to A0 of Arduino. Okay, let's make the circuit. Okay, this is the photosensitive and also have 4 pins. Okay, now we'll connect. 5 voltage is red wire to a VCC. 5 voltage. Okay, next is A0 to analog, and the last one is GND. Okay, GND is green wire. Okay, so now I will write some code to control it when read analog signal from the photosensitive. Okay, right here I have a project. First is serial.begin 9600 to open the serial monitor with power is 9600, and in the loop I have a serial.print. It means we'll print the value and read from pin A0 to the serial monitor. Okay, now we'll connect the Arduino to my laptop. Okay, first I will read the analog signal from the photosensitive first. Okay, upload. Okay, this is the value I read from the analog signal. So now if I turn off the LED, the value will be changed. Okay, let's see. And you see the value is increased more than 700. And now when I put the LED nearby the photosensitive, the value will decrease. Okay, by this condition, I will make an example to turn on LED if the value is more than 700. Okay, right here I have I will use LED 13 is default LED to turn on, and else digital right low, but I have to set up the LED 13 to output. Okay, now if the analog signal from A0 is more than 700, the LED will be turned on, and if not, the LED will be turned off. Okay, I will check the value. Okay, as you see, the LED will be up because the value is lower than 700, but now we'll turn off the LED. You see it's blink because the value is sometimes lower than 700 and sometimes is more than 700. Okay, let's check with if 600. Here. Okay, LED is turned on, right? And now I will put the LED near the photosensitive. LED turn up, right? Okay, now let's check with the next diagram. That's a gas module. Gas module also have 3 pins, VCC, GND, and 8 out, and will connect like the previous device. Okay, and now let's check the circuit. Okay, here I have a gas module right here with 4 pins, but we don't care about the out. Okay, and we use lighter to detect gas. Okay, let's connect. VCC, I will use red wire. GND, I will use green wire. Blue wire. Sorry. And the last one is signal, I will use green wire. Okay, now connect to Arduino. Red wire is VCC 5 voltage. GND, and the last one to A0. I also upload the outcome, but the gas will send the different values, so I will read an analog signal first and then configure the signal to turn on LED. Okay, now connect. Okay, here I will okay, you see the value is increased more than 300. So I will use this value to control LED. Okay, when the value is higher than 300, I will turn on LED. And when the value is lower than 300, I will turn off LED. Okay, but it's quite easy, so I think you can do it. Okay, next I have a new diagram. This is a diagram with microphone. I use this module to connect with Arduino. I also have 3 pins V-in, GD and AC. V-in right here can connect to from 3 voltage to 12, but I will connect it to 5 voltage. Okay, now let's connect. Okay, I have the microphone module right here with 5 pins. Okay, now we'll connect red wire to 5 voltage, green to A0, and blue to G and D. Okay, now I will connect to laptop and let's check. Serial monitor. Okay, the values is 160, so we'll put right here. It also changed, but it's a little bit, you cannot see the change. So now I will open the new serial. This is serial plotter. This is used for microphone, and you see this is the voice sounds and this is noise. Okay, now I will try to blow to the microphone. You see, when I blow to the microphone, the plotter will be changed. And when I tap to the microphone, it will change. Okay, it noise. Okay, so you can use this to read the frequency of your voice and process your signal to control LED or something. So I don't have more knowledge about sound, so the tutorial for this device also have on the Google, so you can search it to make your circuit. Okay, that's the only thing about this video. So next time maybe I will use some LED and some motor to control via analog write. That is the popular application and it's very useful when you use analog write. Okay, thank you. Welcome to Programming Knowledge. Today I'm going to talk about analog output on Arduino. And in this video we will know how to use analog write to output an analog signal. This function on Arduino common call is PWM. That is pulse width modulation. The application of analog write in this video is control speed of DC motor, control phase line of LED from high to low or low to high, and the last one is control RGB LED color. Okay, let's go. In this video there are 3 devices I will use. The first one is motor DCs, the second is common LED, and the last one is RGB LED. And the longest pin of RGB LED is anode, but sometimes is cathode, but the common pins of RGB LED is anode. Okay, you can check by yourself. Okay, to use analog pins on Arduino, there are some pins are support for you to use analog output. That is 11, 10, 9, 6, 5, and 3. All of these pins has a tilde before it, and that's a PWM pins. You only use analog right on the pins had a tilde before it. Okay. And this is the analog right function on Arduino. The analog right has two parameters. The first one is the analog pins. That's the PWM pins. And the second is the value. The value you will transfer is from 0 to 255. That's the 8 bits. And corresponding with analog range from 0 to 1, 0 to 3, or you can understand that is the voltage output from 0 to 5 voltage. Okay, this is, as I said, is the reverse video. Okay, so let's go with the first example. This is the diagram to control DC motor. Okay, first one, I will use Arduino to control speed of DC motor, but I will use the NPN transistor to support, because the voltage of analog pins is quite weak, so it cannot control the motor. So I will base on the transistor operation to control motor. This is the NPN transistor. You see there are 3 pins. First is base, collector, and emitter. Okay, when I supply voltage to the base pins, the collector will connect to emitter. You just understand like that. Okay, and right here I will control the NPN transistor via analog pins, and when I open it, the C will connect to E. That means the 5 voltage will supply for 1 pins of DC motor, and the other pins will connect to GND. Okay, when you connect like that, the motor will run. And don't worry about 2 pins of DC motor, because if you change the position of 2 pins, like if you connect the emitter to red pins and the GND to black pins, it's still okay, because if you change like that, the motor will run the other side. Okay, let's check my circuit. Okay, now we'll connect my circuit like the diagram. I have a DC motor like this with 2 pins and 4 wire and 1 transistor. This is NPN transistor, and this is C1815. You can find it on the website, C1815. And my transistor has 3 pins. From the left to right, the first one is E, emitter. The mid center is C, collector, and the last one is base. Okay, it's different with the diagram, but it has 3 pins like this. Okay, first we'll connect my transistor. Okay, first one is collector. I will connect to the 5 voltage. Collector is the mid pins to 5 voltage. Next is ground to the motor. Okay, ground to motor. Next is connect the emitter to motor. The emitter is orange, and the last one is green. Green for the signal. I will connect to the pin 3. Okay, now we connect to base. Okay, now I have some code right here. I will code for you. You will push the analog right in the setup function, because we just want to set up once pin 3, and I will put the 100 value 100, and you see the let's see the speed of it. Okay, now we can, okay, okay, you can see it cannot run because it's the signal is very quick when I support it. Yeah, you see it's run slowly, but now I will change to 255. This is a maximum value. You see it's faster, right? Okay, and now I will control from slow to fast and from fast to low by using for loop. Okay, disconnect it. I have a for loop for in K is 0, K and analog right, K, and I will copy it but reverse it from 255 to greater than 0 and K plus plus K minus minus, but right here we'll minus 10 and this is plus 10 for faster. Okay, now we'll delay about 1 millisecond. 1 millisecond. Okay, we'll comment this. Okay, let's see. Oh, I forgot. Faster, 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 slowly. Faster, faster, slow, and stop. Stop because the analog signal cannot run the motor. Okay, that's it, the motor. Now I will make the other sample. That is fading LED. I will connect like the diagram. Okay. I have 5 voltage to resistor and resistor to anode. This is 330 ohm, and the other pins of LED will connect to 3, the analog pin. You can connect the analog pins to anode and the cathode to GND. Okay, there are 2 ways to connect the LED. Okay, now let's check the circuit. I have a 330 resistor, LED, and some wire. I will use red wire for 5 voltage. 5 voltage. 5 voltage to resistor. To resistor. To resistor. And then connect to anode pin. The cathode pin will be connected to analog right, analog pins. 3. Okay. Now I will connect. And with the out code, we also make the LED fade. See, as you see is light and fader and lighter. Okay, with the out code like this. Okay, now the other application will control LED. That's either RGB LED. Okay, before connect with the diagram, I will review the RGB LED pins. There are 4 pins of RGB LED. First is red, green, and blue. The longest I will use is anode. Okay, my LED is anode. Okay, this is the diagram. I will connect 5 voltage to the anode pins with the resistor 330 ohm, and 3 rest pins is connected to PWM pins, that is 6, 5 and 3. Okay, let's connect it. 5 voltage, and this is the RGB LED. We'll connect it. I will connect the resistor to the anode pin like the diagram. Okay, connect to 5 voltage, and 3 rest pin will be connected to PWM pin. You can connect like you want, because it still make the LED is light. Don't worry, just connect like you want. Okay, now I will try to run the old code. Let's see what happened. Yeah, the 3 PWM pins will turn on the LED with the blue light. Okay, now we'll code some code with analog write 5 with K, analog write with 6. Okay, now copy it to here and see what happened. Oh, it changed the color, right? It changed the color, but it's quite light, so I will change to from 0 to 250 and decrease this by 1 and 1. Okay, let's see. Yeah. Okay, you see, you can control LED by this way. Okay, this is the reason why I can control LED, RGB LED to what color I want. If you know the color table of the RGB. Okay, thank you. This is a useful application you can do with analog write. Welcome to Program Knowledge. Today I'm going to talk about how to display text on LCD. Okay, let's go. In this video, I will use LCD like this. There are many pixel LCD as 20 multiplied 2, 32 multiplied 2, etc. But I will use the LCD with 16 multiplied 2. It means in this LCD we have 16 column and 2 rows. That means it's 16 multiplied 2. And this LCD has 2 types. The first one is LCD without I2C module. This is the LCD without I2C module, and this is the front side. The back side is like this, but it don't have a I2C module like this. This is the back side of LCD has the I2C module support. This is the I2C module. There are some other function, but with our I2C modules, you have to connect 16 pins. If you don't use the I2C modules, you have to connect 16 pins to Arduino. But as you know, the Arduino we are using has no more pins. So that's the reason why everyone usually use the LCD has I2C module support like this, okay? And the second reason is the I2C modules will help you easily communicate between Arduino and LCD. We just only communicate with LCD via I2C protocol. Yeah, okay. Next is the I2C pins of Arduino. This is the I2C pins. The I2C pins just use 2 pins to communicate with the device. The first is SDA, it means zero data, and the second is SCL, that means 0 clock. Okay, the SDA is pin A4 and the SCL is pin A5, and this is another position, that's a 2 pins right here is next to USB jack. Okay, it's as a method function, but it just are different from position. And with the support of the Arduino community all around the world, they wrote the LCD library for user. You can search that library on Google, but this is a link I see very simple to start with LCD, so I will put this link below the video. Okay, when I click to the link, it will redirect us to this, and then we have to click this link. It will redirect to GitHub. You have to clone all of this to your computer. Okay, and after you download all of this with a zip file, you have to include it to the IDE Arduino. Okay, and you have to click to sketch, include library, and click to add zip library. Then you need to point to your zip file you have already downloaded. Okay, now we try to connect the diagram like this. This is diagram I connect with the Arduino. I have LCD with the I2C support, and this is Arduino Uno. We connect 5 voltage to the VCC, GND to GND, A4 pin A4 to SD8, and pin A5 to SCL. Okay, let's connect. I will use 4 wires like the diagram: black, green, blue, and red. Okay, now we'll connect to my LCD. The green is SCL to connect to A5. SCL. Okay, next is SDA. Connect to SDA. And ground. And the last one is VCC. Okay, we'll use 5 voltage. Okay, done. Okay, now the first thing we have to do before uploading code to the Arduino is we have to find out the address of I2C module. Okay, this is the link we can scan the code of LCD I2C. Okay, I will click on it, and in this link they have some code to scan the I2C code right here. This is code. You have to copy all of this, and okay, we'll pass to the my project. Okay, here, and then you just upload to your Arduino. Okay, now we'll upload to my Arduino. To scan down what is the address of I2C module, you have to open the serial monitor. Okay, it's right here, the I2C device found at address 0x3f. Okay, this is the I2C module's address. Now I will connect to. Okay, now I'll use the code like this. Okay, this is my code. The first one I will include the liquid crystal I2C.h. This is a library of LCD, and you have to include it to your project. The second one is liquid crystal. I to say this will init the LCD with 0 multiply 27. This is the address, but my address is 3F. Okay, and the second parameter is 16. That means 16 columns, and the last one is 2. This is the 2 rows. Okay, address, column, and row. In the setup function, we have lcd.init. This is the init LCD. Okay, just init it. And next is backlight. This means when you run this function, the backlight will turn on. Okay, next is clear. This means clear all characters are being displayed on LCD. Clear for anything will be deleted. Okay, next is LCD set cursor. This means your LCD will start at column 0 and row 0. And next is print hello world to your LCD. Okay, let's check. Now we upload to my Arduino. Check part. Okay, upload. Okay, let's see what happened. Okay, we have hello world, and the first is start from here. That is cursor 0 0. Okay, that's the hello world. Okay, let's check if I don't use LCD backlight. I will use LCD no backlight. Okay, let's upload. Okay, as you see, the backlight isn't turned on, but the character will be displayed. Okay, you can see the hello world, right? Hello world. But the backlight is turned up. Okay, that is the reason why we have to set up the backlight. Okay, and if you want to blink the cursor, we have the LCD cursor right here. LCD cursor, and I will blink it. Okay, first we will try to use LCD cursor. Oh, sorry. Okay, as you see, the cursor right here, but I want to blink it, and we'll use lcd.blinked. Okay, let's check. Okay, it blinked, right? And we have to use lcd.clear right here, because if I bring twice without clear, the character will be replace each other. And before it, I will set the cursor. Okay, let's check. If I don't clear, it will replace the old characters. You see, right here is the D of word. Is something error, right? Now I try to clear it before bring the new character. Right here, I will put the lcd.clear. Now let's check. Okay, as you see, it doesn't display anymore. Okay, we have another function like this: LCD scroll display right or left. So what is that? I will use for you know what is that. Okay. Okay, I have some function right here. Here I have already written it. Okay, just left it here and then copy the lcd.print like this. Okay, clear the cursor and blink. Okay, I will bring the welcome to program knowledge to the LCD, but the welcome to program knowledge will be displayed and scroll left to right. Okay, let's check. Okay, you see the text is scroll left and right, right and left, but it's quite fast, right? I will make it slower. Okay. Okay. The reason why I have the value right here is the 13 is 13 character. It means it will scroll the welcome to programming knowledge to the left until it disappear, and then it will scroll to the right 29 values until it disappear from the right. Okay, let's see, until it disappear, and then it scroll to the left 16. This means we'll set the welcome to programming knowledge to the first column. Okay, this is the reason why 1 2 3 4 16 and 1 2 3 4 5 6 4 5 to the 29th, and then come back to the 16. Okay, that is the reason why I have some correct some variable right here. Okay, sorry, the first one is 13, not 16. Okay, so now if you want to change the speed of text, what I have to do? Okay, I have a diagram like this. I will use the potentiometer to control it. I will use the left pin or the right pin to connect to power. But in this picture, I will use the left pins to connect to 5 voltage, the right pin to connect to GND, and the center pin is connected to pin A0. I will use analog to read the voltage signal from the potentiometer, then I will transfer to the delay function. Okay, now I will connect it to my circuit. Here I have some wire. I also use green, blue, black and red. First, black for GND, red for VCC, green for HCL, and the blue for SDA. Okay, now we'll connect SCL to A5, blue to A4, okay, and the GND to GND, but I have to connect 5 voltage to here for sharing with the potentiometer. Now we'll connect to 5 voltage. Connect here to GND. I will connect like this first, and then I will plug the potentiometer after that. Okay, now the signal to A0. Signal to A0. Okay. Now I will connect the potentiometer. I use the 1 kilo ohm. You can use any variable you want. Okay. Now try some code. I'll use the old code, but I just change this analog read from pins A0. If you all don't remember how to use it, you can watch the old video. That's the analog read and write. Okay. Okay, now we'll connect my Arduino to my computer and then let's check. Okay, now I will upload my code. When I turn the potentiometer, the speed will be changed. Okay, now we turn it to left. It's low, but now we change it to right. Faster. Okay, as you see, it's faster. Now we'll try again. Turn to left, turn to right, turn to left, right. Okay, that's the only thing about how to control LCD, and you can use the other library as you want, but the library I recommend is very easy to use, so you can try it before you use the other library. Okay, thank you for watching. Welcome to Programming Knowledge. Today I'm going to talk about how to control servo. Okay, let's go. Servo is a device is quite similar with the step motor, but it isn't exact as the step motor. Okay, this is the inside of servo. This is the control circuit. It is integrated from H-bridge. The H-bridge is the circuit we usually use to control the motor. That's just a circuit help you open and close the control signal from the microcontroller. Okay, the servo, to control the servo, we will use the PWM to control this circuit, to control the control circuit. And the control circuit will control the DC motor and potentiometer at the same time to operate the gearbox. Okay, the potentiometer will affect to the angle and the DC motor will affect to the speed, and the gearbox can up to 60 RPM. There are many types of servo, but I have some popular servo like this. The first is blue servo. This is the cheapest servo and the quality is quite good. It can pull about 1.8 kg when we supply it 4.8 voltage, and it can be pulled 2 kg when we supply it 6 voltage. And this just approximate. Maybe it can pull 1.5 or higher. Okay, because it's just approximate. The blue servo can rotate from -90 to 90. That's 180 degrees when you plus it together. And the next is black servo. It's more expensive a little bit, but the quality is more stable. And it can rotate approximate 200 degrees. Okay, the information estimate with the blue servo and the information right here is just approximate, and it's just a theory. Okay, and the last one is MG996R. This is the most expensive in 3 types, but the quality is good and it can be pulled stronger. When you supply 4.8 voltage, it can be pulled 8 kg, and with 6 voltage, it can be pulled 10 kg. And the angle also 180 degrees. There's some type of servo 360 degrees. Okay, but I just use 180 degrees to make an example for you. And in this video, I will use the black servo to make an example. First of all, before we use PWM to control the servo, I will create a PWM signal by set high or low level the digital signal from the Arduino with the function that is delay microseconds, and this is the time parameters. We will transfer the time parameter to right here. Okay, this is how servo work. We use period is 20 milliseconds. If you want your servo is rotate to 0 degrees, that is called minimum pulse. You have to make an output as the digital pins is high in 1 millisecond, and then off. It means make an output low voltage in the 90 millisecond left. And when you want your servo is at the mid is in 90 degree, you have to make an output at the digital pin at 1.5 millisecond. And the other, when you change to 180 degrees, you have to make an output is 2 millisecond at high voltage, okay? And low voltage is 80 millisecond. Okay, that's how control the servo by digital signal. Okay, now let's check the diagram. I have a diagram right here. The servo has 3 pins. The orange is the signal. I will connect to the pin 9. You can connect to the other digital pin, okay? But I will connect to the pin 9 for the PWM function after that. And the mid is the red. The red is connect to 5 voltage. And the last one is ground. Okay, let's pick the circuit. I have a black servo right here. And it also have 3 pins, orange, red, and GND is corresponding with the signal VCC and GND, okay? And I have also used 3 wire as the diagram, that is red, green, and black. Okay, now we'll connect to my servo. With red is VCC, green is signal, and the last one is GND. Okay, now connect to the Arduino. Signal to pin 9. VCC 5 voltage. And the last one is GND. Okay. Okay, before we control, I have some code right here. This is the code to control the servo by digital signal. I use pin 9, so I will make the pin 9 as an output. Next, in the void loop function, make a high level at pin 9 and then delay 1 millisecond. But right here I will use microseconds, so I will use 1000 right here. And then I will make an output low voltage. But right here I have to change it to 19,000. Because my period is 20 millisecond. Here 20 millisecond, and if I make an output with high voltage in 1 millisecond, I have to make an output for low voltage in 19 seconds. Okay, and right here 19 seconds. Okay, now let's check. Okay, it's quite approximate with 0 degree right, but right here is quite noise and approximate with 0 degree, so it can run to here. Okay. Oh, there's something wrong with my servo. And when I supply is with 0 volt, 0 degree, I can move it. It's quite hard to move. Okay, now I have to change it to 1500. Here is 1A5. Okay, let's check. It will rotate to the mid center. Okay, as you see, it will move to the center. That's a 0 degree. And the last one, I will change to 2000. And here is A0. Okay, let's check. It will turn to the left. Okay, you see? It changed to the left. Okay. Okay, now we have to control it via PWM, and before that we have to know what the analog pins. The PWM pins is the pins had a tilde before it. Example 11, 10, 9, 6, 5, and 3. Okay? Just these pins can use PWM to control the servo. And to control the servo, I have a servo library in IDEA. We have the servo library inside the IDE Arduino. You have to move to File Section, Example, Servo Section, and select to Sweep Project. Okay, let's check. I have to move to Example, Servo, and Sweep. Okay, this is the sample code. So now I will use the node diagram. Okay, the node diagram is also assembled with the old diagram. I also connect it to the pin 9. Okay, let's check. See what happened when I upload the script project to the Arduino. Okay, my Arduino is rotate from the left to right and then from the right to left. With my servo on the right is 0 degrees and on the left is 180 degrees. Okay, remember that. Just my servo. And here this is some code. The code right here is rotate from the 0 degree to 180 degree. And then it's rotate from the 880 degree to the 0 degree. Okay, that means it's run from the left to right and right to left. Okay, it's easy, right? Now I have another sample. That's it. I'll use the potentiometer to control the servo. Sample when I turn the potentiometer to left or right, the servo will rotate like the potentiometer. Okay, let's check the diagram. This is the diagram. The diagram is I will connect to Arduino to servo, and the left pin of potentiometer is 5 voltage, and the GND of servo with the right pin of potentiometer to GND, and the center pin of potentiometer will connect to A0 to read analog, and the signal of servo I will connect to pin 9. Okay, let's connect the circuit. Okay, let's check my circuit. Right here I have 3 pins of servo is connected to 3 wires. Okay, but 5 voltage I have to connect to the test board because I just have one 5 voltage on Arduino. Okay, and with potentiometer I will use the 1 kilo ohms. Okay, you can use the other value, but right here I will use 1 kilo ohm. Okay, we'll connect to test board. Okay, ground of servo I will connect to ground of Arduino. And this is the signal of servo I will connect to pin 9. Okay, now I will use the yellow wire to connect 5 voltage to the potentiometer. That is the left pins. Okay, I will connect to 5 voltage here. Okay, now use the orange as the diagram to connect to A0. That is analog pins. Okay, we'll connect to A0. And the last one is ground. I will connect to the right pin of potentiometer to ground of Arduino. Okay, and the last one 5 voltage to 5 voltage here. Okay, you can see it. Okay, now I will code some code for you. First of all, I have to check the analog read from the potentiometer. Okay, comment it, delete it. I'll use the serial monitor to print out the value of potentiometer. Okay, serial dot begin at 9600 baud rate. Okay, right here I will print out the value from analog at pin A0. Okay, I will connect my Arduino to laptop and check what happened. This is the old code, but don't worry about that. Okay, let's check. So the serial monitor is opened. Okay, this is the value of potentiometer. Now we'll turn to left. Turn to left, the variable is increase, and max is about 940. Okay, the max is 940, and the mean is 0. Okay, let's check max again. Okay, max is 940. It's approximate with 1030. Okay. Okay, now I have to convert that variable to the decrease we want to control. Okay, I have max is 940 and the decrease of us is 180. Max mean is 0, right? And the variable mean is 0. Okay, now we take the 940 divided by 180. Okay, 940 divide 180. That about 5. Okay, we will take the integer 5. Okay, now use 5 to multiply the variable to get the control signal. I'll use the sweep. Okay, right here I will delete. Okay, remember this function is control the servo. Okay, now I will have a int variable right here. I will put the name is read analog is from analog pins A0. Okay, and then convert. I have a variable convert. Okay, convert is read analog divide by 5. Okay, divide by 5, and then I will transfer the convert here. Okay, now let's check. Upload. Let's check my servo. My servo is rotate to left, right. Now I will turn the potentiometer to right. Okay, let's see. Right. Okay, and then try again. I will turn to the left. Okay, that's how I control the servo from the potentiometer. You can use this way to control with the other analog device. You can read the analog signal from the other device and then control the servo to do what you want. Okay, thank you for watching the video. Welcome to Programmer Knowledge. Today I'm going to talk about how to use keyboard with PS2 type or USB type. So in this video I just make an example with PS2 type because they are asymmetric each other, and then after introduce you to PS2 type I will talk about USB type a little bit. Okay, let's go. First I will introduce you female PS2 connector first. This is the female PS2 connector. It has 6 pins, but we just use 4 pins. We don't need to use pin 6 and pin 2. Okay, the 4 pins left is clock, HID, data, and 5 voltage supply power. Okay, this is the front side, and in the back side we also have 6 pins and we only use 4 pins. This is clock, this is ground, this is data, and this is 5 voltage. Okay, you have to connect to your Arduino. Okay, remember that. This is how keyboard works. We have a signal diagram like this. When we press any keys on keyboard, the keyboard will transfer via data pins a packet. Each data packet consists of 11 bits. These are 1 start bit, a data bit, 1 parity bit, and 1 stop bit, like this. Okay, first, the keyboard will pull down the clock pins from high to low to announce for Arduino is start, and then send a bit data via data pins, and then send parity bit and stop bit. Okay, that's how the keyboard work. Okay, and on Arduino we have to decompose those signals and then compare with the default keyboard scan code table. Okay, this is keyboard scan code table. Each key on keyboard has the individual scan code. Example, if I press the key A, the keyboard will transfer a packet to Arduino, and Arduino have to decompose that signal. And after decompose that signal, the Arduino know what is data and then bring out the 1C2 serial monitor and the other like that. And these signals are very fast, so simple pulling pin state would be too slow and we could lose some data. Because of this, we use external interrupt pins on Arduino to get the data. Here, this is the 2 interrupt pins on Arduino Uno. With the keyboard, we just use interrupt pins to receive data. We cannot use the other pins because, as I said, we can lose data when use the digital pins. We must use the interrupt pins. Okay, and we can use interrupt 1 or interrupt 0 to receive data, but in our library we are going to download, they use interrupt 1, so we only use interrupt 1 to communicate with the keyboard. Okay, remember that. I will use interrupt 1 in this video to communicate with Arduino and keyboard. Okay, next is the Arduino library link. This is the link of Arduino library. This is the link, and there are many type of library right here, and the newest version is 2.3, but we have to use PS2 keyboard 002 because it's quite easy. Okay, I will use PS2 keyboard 002.zip in this video for easy. And after we download the library, we have to move to sketch session, include library, and then add .zip library to the Arduino IDE. Then we have to edit some code in library because with some new Arduino IDE version, it can be error when use the old library. Here, we have to move to this directory, this PC, documents, Arduino, libraries, and move to PS2 keyboard folder. After you import your keyboard library to your Arduino IDE, you will find out PS2 keyboard folder. If you cannot find out the PS2 keyboard folder, you have to import your library first. Okay, and then we have to open the PS2 keyboard.cpp. Okay, we have to edit some code in this file. This is the 2 old line. I've commented it. We have to replace 2 lines above to 2 lines below. Okay, we have to use unsigned char constant. It's okay when we change like this. And then when you edit, you have to save the PS2 keyboard.cpp. Okay, this is the diagram between PS2 connector and Arduino. we have to connect 4 pins. First is 5 voltage to 5 voltage, GND to GND. The orange line is clock. We have to connect to interrupt pins. That is pin 3, and this is the interrupt 1. And the last one is green. This is the data. We have to connect to pin 4 or any pin you want to connect. Okay, but remember the clock pins we have to connect to interrupt pins of Arduino. Okay, remember that. Before connect the diagram, we will code. Okay, first of all, we have to include PS2keyboard.h. Okay, then we have to init the PS2 keyboard by PS2 keyboard, and this is the name. You can put it in my keyboard. Okay, and then in voice setup, we have to init keyboard my keyboard.begin, and this is the data pin. Okay, we use the pin 4, so I will transfer the 4 to this, and then we have to init the serial monitor with 9600 baud rate. Okay, in loop function we have if my keyboard dot available. This means when we press anything on keyboard, the Arduino is detect we press, so it will accept this function. Okay, and then we have a variable is byte data receive is my keyboard.read. Okay, we have to assign my keyboard.read to data receive as a byte because the data received from keyboard as a byte. Okay, and then we have to print out this data to serial monitor as a hexadecimal because our data is hexadecimal. Okay, now let's check my circuit. Okay, I have the female PS2 like this, and I soldered some wire to this. This is clock pins. This is brown is GND. This is white for data, and the last one is blue. Blue's for 5 voltage. Okay, and I have 4 wires like the diagram, but I will replace the yellow one to red one. Okay, first is red, yellow I will connect to 5 voltage. Okay, I will use a breadboard to connect 2 devices for more stable 5 voltage. GND to the GND in this 5 voltage above and GND below. This is clock E orange, and clock I will connect to the pin 3. This is interrupt pins 0, 1, 2, 3. Okay, this is 3. I will connect below, and the data pin will use green wire. This is pin 4. Okay, I will put it to the above. Okay, now connect this PS2 keyboard to the breadboard. This is clock is orange, brown is ground here, and white is data is green, and the last one blue is 5 voltage. Oh, it's quite hard. The last one blue is 5 voltage. Okay, now I will plug my PS2 keyboard to the PS2 connector. Okay. Okay, now I will connect my Arduino to laptop and upload the code. Like this. Okay, now we uploading code and then open the serial monitor. Okay, now I will try to press some key on my keyboard. I will try to press A, B, C, D, and E. Okay, this is the hexadecimal character. So I will compare with the keyboard scan code. Okay, here. AE1C, BE32, right? And CE21, DE23, and E24. Okay, this is E24. Okay, that's the house keyboard work. And now I will have application like this. I will check if I press key A, the Arduino will print A to serial monitor. Okay, if data receive is 0x1c, I will print serial dot print A. Okay, you can try with the other character, but I just want to make an example with A. Okay, let's check. I will uploading code. Okay, now we check with A. Okay, here when I press A, it will print A, and then it will print the hexadecimal A. But when I press B, it just prints the hexadecimal because I don't check the B key. Okay. Okay, and the last one, this is a USB type, and this is a diagram of USB cable. This is a female USB, and it has 4 pins. On the left is VCC and on the right is ground. The 2 pin center on the left is D minus and the other is D plus. And the D plus is clock and the D minus is data. You should connect those pins to the Arduino like the PS2 type. Okay, it also have data, clock, ground, and VCC. Okay, let's try it with yourself. Okay, thanks for watching the video. Welcome to Programming Knowledge. Today I'm going to talk about how to use the keypad voice 4 on Arduino and how to use it. First of all, we have to code the keypad voice 4 by hand, and then we will use library for easy. Okay, let's go. This is the pinout diagram of keypad voice 4, and as you see on the left, that is the circuit inside the keypad, and on the right is the keypad I will use in this video. The keypad has 8 pins. From the left to right, first 4 pins are rows, and the rest pins are column. Okay, the circuit inside the keypad, each pins is a button. One pin up button is connected to rows, and the other pin is connected to column. All up button in a rows are connected together with the pin left, and with the pin right are connected together in a column. Okay, as you see. Okay, next is how we initialize the keypad. First of all, we will set output to rows and set input to column. Okay, and with row we will set low voltage output. It means we will uh, make an output on rows the output low voltage, and with the column we will set input pull up. This is the internal resistor. If you don't know what is it, you can watch the previous video. Okay, and when we set the input pull up, it means the column has default status is high. Okay, it's always high and always wait to receive the signal from the peripheral device. Okay, and after we initialize, this is the keypad status. As you see, all the rows are low voltage and all the column are high voltage. Okay, next we will know how to check the press. I assume I will press the key 8. Okay, I will press the key 8, and after I press the key 8, the C2 will receive low signal from R3. Okay, R3 will transfer the low voltage to the C2 because I pressed the button key A, and because I pressed the key A on the row C2, so we just check the row C2. Okay, first of all we will set the R1 to high voltage. This means we will change from low voltage to high voltage. Okay, and then we will check whether the C2 status is changed. This means we will check this column. If it changes from low to high, we will know the key in this column is pressed. Okay, if not, check to the next row, next row, next row. If it changed, we will print to the serial monitor for user know. Okay, and then we will set all rows to low again to check the other. Check here, we will have to check the next row. Okay, next we will set R2 to high voltage, and then check whether C2 status is changed. Okay, but it doesn't change, so check the next row. Okay, check the next row, and in the next row, the row 3 set high voltage, and then check whether the C2 status is changed. At this time we see, because I pressed the key 8 and the key 8 on the row 3, so when I set the 3-2 to high voltage, the column 2 will receive the high signal. So if change bring to 0, now I will bring the key 8 to serial monitor and then set all rows to low again. In this step we have to print and then done. But if I press the key on the last row, we have to check it. Okay, this is the diagram of keypad and Arduino. On the left is the rows and on the right is the column. I will connect row to the 4, 5, 6, 7, and I will connect the column to the 8, 9, 10, 11. Okay. Okay, now I will code first. Default, we have two default function, that is setup, and the second is loop. Okay. Okay, in setup, as I said, we have to set all rows is output low voltage. So my row is from 4 to 7. So this is from 4 to less than 8 E plus. Okay, this we have pin mod if output, and then digital write low voltage to E pins to low. Okay, and then to the column, this means set on rows output low voltage. With the column, we have to set it to input pull up. So we have from in E is 8 to 12, because we from A, 9, and 11. In mode E input pull up. Okay. This is set on column is input with high status. Okay. Okay, that's it. Initialize the keypad. So now we will check the press button on the column 2. I have submitted rep key 8. So I will check this column. Give you the algorithm like the slide. First set R1 to high. And then check C2. Okay. But first of all, I will determine the column I want to check. That is the column 2, right? Because the key 8 on the column 2 and the column 2 is connected to pin 9. Okay, if digital read 9 E0, that means when I press the button in the column 2, okay, the column 2 will be pulled to low. Okay, now we will set the R1 to high. Digital right R1 right here is pin number 4. High. And then we will check the C2. If digital read 9 E0, we will print out to the serial monitor. Okay. Serial.print. Print the first key is 2 because this is the first situation. Okay. And if the user don't press the key 2, we will check the next. Else, right here we will set to the R2 to high and check C2 again. Okay. Right here I will digital write 5. The R2 is in 5. And next check digital read 9 E0. Okay. If it change, I will print to the serial monitor. Key 5. If not, check again. Else, right here we set R3 to high and then check C2 again. Okay. Digital write. My R3 is pin 6. And next, check the column 2 0.print. Okay, right here I will print 8. Okay, we can stop at this step, but if I press the key 0, okay, I will lose it. Now I will check on the rows to know which keypad is pressed on a column. Okay, so I also check the key 0, digital write 7 is the last row. High. And if digital read 9 E0 0.print 0. Okay, 0 is the last key on the row 2. And else don't do anything because the key 0 is the last key. Okay, I forgot here. Okay, and then we have to set on the row to low again for check the next key. For in I bằng 4 e less than 8 e plus plus, and then digital write e to low again. Okay. Sorry, this we will check it change from low to high because so I will change it to high. Sorry, high. This is high. This is high. Okay. Okay. Now I will connect my circuit. I have already connected some wires to my keypad, so now I will connect to my Arduino. Okay. First, I will connect rows to pin 4, row 2 to pin 5, row 3 to pin 6, and the last row to pin 7. Okay, and next to the first column to pin 8, 9, 10, and 11. Okay, okay, here. Now we connect my Arduino to laptop. Okay. right here. Okay. Now I will upload my code to the Arduino. Let's check what happened. Okay. You know, and 17. Okay, let's upload and check the serial monitor. Oh, sorry. Okay, let's check. Okay. Now I will try to press 2. Oh, nothing happened. Okay, let's check again. Sorry, I forgot to 0.print in 9600. Okay, again. Okay, now I will press 2. As you see, the key 2 is print to the serial monitor. I will press 5, press 8, and press 0. Okay, but you see, it's print too fast, so I can determine which key is print, which key is pressed. So I will put a delay right here. 5, 0, 0, 0, 0. Okay, now let's check. It will check the press key slower. Okay, now press 2, press 5, press 8, press and hold a little bit. Okay, 0, 2, 2, 2, 5, 5, 5, 8, 8, 8, 0, 0. Okay, this is how we use the keypad from algorithm. So now I will use the library to use easily. Okay, first of all, you have to move to Sketch, include library, manage library. Okay, and then you have to type here is keypad, and you need to find the keypad by Mark Stanley. Okay, the version you can download any version you want, then install. Okay, after install, you have the library of keypad on Arduino IDE. Okay, now we'll open the example of keypad from library. Okay, you move to Files, Sample, find the keypad. Here, keypad and custom keypad. This is the project custom keypad. Okay, but right here, you see, you have to change a little bit about key on your keypad. With our keypad, we have 1, 2, 3, 4. Oh, sorry, 8. This is 4, 5, 6, B, 7, 8, 9, and this is C, this is D, this is 0, 0, this is star. Okay, after that you have to change the rows and the column. This is 4, 5, 6, 7, and this is 8, 9. You have to change it 10 and 11. Okay, everything is done. Now I will upload to my Arduino. Open the serial monitor. Now I will try to press 2. Okay, 5, 8, 0, 1, 4, 7 star, 3, 8, 6 B, 9 C. Okay, you can see it. All of the keys print to the serial monitor. Okay, this is the way you use the library to use keypad for easily. Okay, besides that, you can use the code of yourself to easy handle. Okay. There are two ways to use this, and there are many projects right here of keypad. You can check it to see what happened with your keypad. Okay, thank you for watching this video. Welcome to Programming Knowledge. Today I'm going to talk about how to use the RFID module. Okay, let's go. This is the module I will use in this video. This module helps us read RF tag or RF tag when I put them near the module, okay? And it operates at 13.56 MHz. It's quite stable and cheap. This is two RF tag and RF tag are included when I buy this module. So with this module, we can communicate with the Arduino via SPI protocol, I2C protocol, or UART protocol. But the library I will use in this video also supports SPI protocol, so I will use SPI protocol in this video. First, I will show you how to connect module RFID to Arduino. Okay, this is the diagram. With the module RFID, we have 1, 2, 3, 4, 5, 6, 7, 8 pins, but we don't use the IRQ pins. Okay, don't care about that. We just use 7 pins on the module. Okay, first of all, we will connect SDA pins to pin 10. Next is SCK pins to pin 13. Next is MOSI, I will connect to pin 11. And MISO, I will connect to the pin 12. Okay, and GND with GND 3.3 voltage with 3.3 voltage. Reset will be connected to pin 9. Okay, with this you have to pay attention about this. With the RFID module, you have to connect to the 3.3 voltage to supply to module. Please don't connect to 5 voltage, it can be burn your module. Okay, this is the URL RFID Arduino library. You can move to this to download the RFID. Okay, when you move this site, you have to clone all of this with zip file to your computer. Okay, after you download, you have to move to Sketch, include library, and add.zip library. After click add.zip library, it will appear a windows. So you need to point to the file you have just already downloaded. Okay, and click OK. Now I will give you an example to open a project after you download the library. Okay, you move to File, Example, and move to RFID here. RFID MFRC522. This is the name of module. Okay, there's many projects you can check right here. Okay, but first I will test the module RFID to know whether it runs stable with the firmware check. Okay, I will upload this code to my Arduino, but first I have to connect my Arduino to the module RFID card. Okay, let's check. Okay, this is my RFID modules. I have already connected some wires. So because I don't have enough colors of wires at the diagram, so I will use the different colors from the slide. Okay. And this is two RF cards and RF tag. Okay. Now I will connect like the diagrams. First of all is 3.3 voltage. Please pay attention, don't connect to 5 voltage. Okay. .3 voltage. Next is reset pins. I will connect to pin 9. Okay, next is ground. I will connect to GND. Next is MISO. The MISO is connected to 12. 9, 10, 11, 12. Next is MOSI. MOSI will be connected to 11. 7 here. And next is SCK. SCK we connect to pin 13. And the last one we will connect to 10. That's a SDA. Okay, done. So I will connect my Arduino to the laptop and upload the code, upload the check firmware. Here, firmware check. Okay. Now we check part and upload. Okay, we open the serial monitor to see what's happened with my module. Okay, you can see our MFRC 522 digital self-test firmware version is 092 ver 2.0 and performing test is okay. Okay, my modules is operate okay. Okay, now I will use the other project to read the RFID card. You also move to file, sample, and move to here. RFID default keys. Okay. Okay, you can use this and okay. Now let's upload code and open the serial monitor. Okay, now I will try to scan the RFID tag, RFID card. Okay, let's see. Okay, the card UID, that is the card serial number, that is 67 EB, E1 and 34. Pick type, this is the type of card. Success key, this is the key of success. And this is block 0. It means that when you scan the RFID card, the Arduino will receive a block 0 like this with the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You will receive 16 bytes and pay attention about this, okay? The just first 5 bytes or 4 bytes is different from the other card, and the other here the rest of bytes are as the same because this is include parity check, information about module or something. Okay, now we'll test with the tag, or you see the difference with the first 5 bytes. Okay, you can see it's different from each other, so you can use first 5 bytes or first 4 bytes to use to make your RF card number, but in this they use 4 bytes. Okay, for first 4 bytes to use the serial number. Okay, let's check again. Okay, now I have an application is check card to open a LED. Okay, I will use pin 7 to control LED, and I will turn it on when my white RF card is scanned, and I will turn it off if there are any the others RF card or RF tag is scanned. Okay. Okay, here this is a white RF card 67 EB, E1 and 34. I will copy it. Copy by Control and C. Okay, next I will use this link to convert hex to decimal because what I see in serial monitor is hexadecimal. Okay, I will paste to this hex and okay, sorry, 0x 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 0x. This is a decimal value correspond with your RF card. Okay, you can use this to check your RF card by combine 1 by 1 to a string. Okay, I will open the RFID default keys to read keys and check it if in my white RFID card. Okay, now I will create a
string my decimal or RFID card. Okay, and I don't put anything in this string. Okay, and in this I will combine one by one character I read from the RFID cards. Okay, by plus is buffer I. Okay, then we move to main to check it. Main here. Okay, main here. I will check if my decimal RFID card is the string I combine. The string I combine is decimal. Okay, I will open here and copy on this, pass to here. But remember that between of them don't have any space, so I will delete it. And you have to pay attention here. With the 2 digits number, you don't have 0 before it, so I will delete the 0 and delete the space. Okay, this is the decimal serial number of white card. Okay, as the decimal. Okay, if my string as the RFID, I will turn on the LED 7. High. If not, I will turn it up 7 low. And after all, I have to update the my decimal RFID card again. By this, I will turn it here. Is nothing, because if I put it here and in this function it will call my decimal RFID card again, so I cannot put it here. I will put my RFID card right here to update it. Okay, and I have to set the pin 7 to output first instead of function right here. Pin mod 7 is output. Okay, now let's check my circuit. Okay, this is my circuit. I will connect the LED to pin 7. Okay, we connect to test bar, and then from test bar we connect to pin 7. Pin 7 is anode and pin chini to cathode. Okay, now I will connect to my laptop, and now I will upload my code. Okay, let's check. Upload. Okay, upload again. We open the serial monitor. Oh. Okay, now we try to scan this white RF card. Okay, it's on, right? The LED is on. And now I will test with the RF stack. It's off. Off. Off, off. Now I will turn it on and off. Welcome to Programming Knowledge. Today I'm going to talk about LED matrix 8x8. Okay, let's go. This is the LED matrix I will use in this video. It has 8 rows and 8 columns. Both of them are 16 pins. Okay, this is the circuit diagram inside the LED matrix. There are 2 types. On the left is the Cohen type. All the anode pins of this type are connected to rows, and all the cathode pins are connected to column. And the diagram on the right is reverse. All the anode pins are connected to column, and all the cathode pins are connected to row. But pay attention, actually the rows and the column aren't short like this. It doesn't short by column 1, 2, 3, 4, but actually the column right here is maybe row 1, column 2, row 4, column 7, column 8. Okay, it doesn't short like the diagram. Okay, pay attention about that. And because my lab magic is different from the other on the internet, so I don't put the pin's name. So I don't put the pin names right here. Okay, and I will give you an example to turn on one LED. I will give you an example if I want to turn on this LED. Okay, this LED, I have to make an output at column 4 is high level, and at the same time the row 3 is low level. Okay, this I will set high at the column 4 and set low at the row 3. This LED will be turned on. And the reverse on the left, if I want to turn on this LED, I have to set the column 4 is low and the row 3 is high. Okay, it's reverse each other. But in Arduino, do you remember if you want to set an output pins, you have to put a pin mod function in the setup function. Okay, and I want to turn on all of this, so I have to set a pin mod on of this pin. So, and on the Arduino, when I set pin mod, the pins will be high level when I set pin mod. So if I set the row 3 low, all of the LEDs at these rows are turned on. So please don't surprise when you see it. Okay, and I will use code M type, and my LED magic is code M type. Okay, now I will give you an example to create a ladder on LED magic. I assume I will create ladder A. Okay, here this is a LED matrix, and if you want to create a ladder 8, I have to create one by one rows. Okay, first of all, I will turn on this LED and this LED at the same time, like the method as the previous slide. Okay, and next I will turn on the second, third, fourth. Okay, next, and I will turn on 8 times to create this ladder. Okay, I will turn on one by one, but when I turn on with the fast speed, we cannot see it be delayed, and it will display a ladder by this method. Okay, it cannot be delayed if you set in the fast speed. Okay, this is the LED matrix example code. You can move here to copy all of code and pass to your Arduino sketch and upload to your Arduino. Okay, and this is the diagram. Okay, I don't put the row names and column names right here, but you should connect like this diagram. But if it doesn't run, you have to turn around. Okay, you have to turn around the LED matrix if it doesn't run. Okay, this is my circuit. I have already connected like a diagram. Okay, now I will uploading the code. Okay, uploading code and see what's happened. Okay, as you see. Okay, as you see, the letter A is displayed on the LED matrix. Okay, and I will show you how it works. If I set delay right here, delay about 200 milliseconds. Okay, now we'll upload. You will see how it works one by one. Yes, first, second, third, fourth,
fifth, sixth, seventh, and last. Okay, this is how it's work like I told you. Okay, and with the fast bit, when I delete the delay, you cannot see it be delayed, so it will display the letter 8. Okay. Letter A, right? Okay, and now I will show you how to create the letter A's. Here. This is the code for letter A, and this will put in the array. First, second, third, next. Okay, this is the code, and where the code is here. This is the code here, byte A, and has some right here. Okay, now I will open the slide and move to this link to copy the example code. I will copy the letter A. No, I will copy the letter B. Okay, the letter B. The letter B here. And put to this. But you have to edit this. Okay, B. And let's upload. Okay, and you see B. So how it works? Let me explain this. This is the first row, 0 0 0 1 1 0 0 0. It means turn off, turn off, turn off, turn on, turn on, turn off, turn off, turn off. Okay, just like that. There are the rows like that, and you can create the letter you want, or you can create the picture you want. Example, I have a heart. Okay, I don't have a heart right here, but I will make an example with 7. 7. Okay, do you see the 7? Okay, by this way you can create for yourself any letter or any picture you want. Okay, I will make a sample to create a heart. With the heart, I have. Okay, let it copy the code. Okay, this is the heart code. Upload. Sorry, I forgot to edit it. Yeah, you can see this is a heart. Okay, thank you for watching this video.
Welcome to Programming Knowledge. Today I'm going to talk about Sonar module. Okay, let's go. This is the Sonar modules that we use in this video, and its name is HCSR04. This module is quite popular to learn about it, and the community around the world usually use these modules to detect objects. Okay, and on these modules there are 4 pins, VCC and GND. These modules operate at 5 voltage, and 2 pins right here. The first one is trigger. This pin will receive a signal from Arduino, and this is the echo pins. The echo pins will transfer a signal to Arduino. Okay, signal in from Arduino to trigger and signal out from modules to Arduino. Okay, and as you see on the left is a solenoid transfer because it has a T right here, and on the right is solenoid receiver because it have a R right here. Okay, this is how the modules work. First, the solenoid transfer will transfer away to the object, and then the receiver will receive the reflected wave is echoed from the object. And the distance between object and modules is the distance we will find in this video. Okay, let's start. We will know how to get the distance to detect object. First, we have to get the speed. Okay, we have to know the speed of sound. Okay, to know the speed of sound, we'll click here. You can search it on Wikipedia about speed of sound. Okay, scroll down here about is follow to temperature. So my temperature right here about 25 to 30, so I will plus to this speed of sound and divide by 2. Okay, 349 plus 346 is, and divide by 2 about 347.5. Okay, 347.5, and this is meter per second. Okay, but the second is too large to calculate because the signal is fast, so we will convert it to the microsecond and centimeter. Okay, move to Google and search to centimeters. Here we will convert from meter per second to centimeter to per microsecond. Okay, we have 347.5, and after convert we have 0.03475. Okay, after we convert we have 0.03475 centimeter per microsecond. Okay, and this is the speed. Okay, we can get the speed, and the second we will get the duration. That's the time. You can call it the time. Okay, as you know, the transmitter will transfer and receive in a time, so we can call it a period. Okay, a period. You can call it ET. The period time is transfer plus receive. Okay, a transfer and receive in a time. So to calculate the distance between the modules and the object, we just need to calculate a receiver time. So we will make a T divide by 2. We can get the time. Okay, and the last one, we have a basic physical formula right here. If you want to get the distance, okay, we have distance is speed multiplied by time. Okay, we have distance is v multiply time 0.03475 multiply with t divided by 2, and this distance is centimeter. Okay, so we will move to coding. Okay, before to send a signal to start, we will send a low signal right here to ensure a clean high pulse. Okay, and then we will transfer a signal in 5 microseconds or more to start, to trigger the trigger pin to start to transfer a wave to the object. Okay, and then to read the signal, to read the reflect wave from the object, we will use the pulsing function to get the time between high and low signal. Okay, example, I have a signal right here. The pulsing will help us calculate the time between this. Okay, pulsing, this is the pins. Okay, pins, and this is high. High mean it will calculate high when the signal is high, and but if it's low, it will calculate the signal. Oh, sorry. Oh, it will calculate the signal right here. Low signal. Okay. It will return a integer. Okay. And that's how the pulsing work. Okay, and then we will assign it to duration. Okay, pay attention. We will use the delay microseconds right here. We don't use the delay as the reverse video. Okay. Okay, and this is the diagram. We have 4 pins, VCC to 5 voltage, GND to GND, and trigger pins I will connect to pin number 6, and the echo pin will be connected to pin number 7. Okay, let's check my circuit. Okay, this is my circuit. I have 4 wires as the diagram: red, black, orange, and green. Okay, and this is my sonar module. I also have 4 pins like the diagrams: VCC, GND, trigger, and echo pins. Okay, I will put it to the breadboard test board. Okay, and now I will connect one by one. High voltage, high voltage, G, GND, and I will connect 2 pins, the trigger to pin 6. The last one to pin 7. Okay. Now I have a project right here. Okay, this is the code and the trigger pin 6. I code pin 7. I set up the serial begin to read the distance. With the trigger, as I said, that is the output and the echo is input. Okay, input from module and output to module. Okay, right here, set low to clean high pulse and trigger to start, and then read the pulse. And time right here, I will set the duration by divide by 2 as I said, and speed right here is 0.03475. Okay, and I will code as the formula distance by time plus speed. Oh, sorry, multiply with speed. Okay, and this is float to get the point. Okay. Okay, now I will connect to my Arduino. Okay. Uploading code. Open the serial monitor. Okay, is reading to the serial monitor is 15.95. Okay, 15 and between 15 and 16 centimeter, because I have a phone record right here, so it's detect the phone, and the distance from the phone to the modules about 15 or 16 centimeter. Okay, now I will try. Okay, I lost the signal, so I will check again. The button is right here. Click. Okay, this will take my hand longer, far further, and starter. Okay, you can use this module to detect object, to turn on LED or do anything you want. Okay, thanks for watching this video. Welcome to Program Knowledge. Today I'm going to talk about module sim topic. Okay, let's go. This is the module sim's name we use in this video. That's name is sim 9008 mini. It's quite small, right? It has 1, 2, 3, 4, 5, 6, 7, 8 pins, and the one hole right here it will support you plug the external antenna. Okay, because right here this is the default antenna on these modules and it's quite bad. So I think you have to break this this antenna and replace it with the external antenna to get the better signal. Okay, and if you want to plug the external antenna, you have to break it out. Okay, because on the modules you just only use one antenna. Okay, and there's some antenna you can choose right here. First, you can use the antenna of NRFL01. This is the module RF. Okay, you can use this antenna, and the other you can use this antenna. This antenna usually used for the module SIM. Okay, and the last one you can buy a module SIM is integrate with the antenna like this. Okay, but it's more expensive than the modules I give you. Okay, and to use the module SIM, we have to use the UART protocol to communicate with the circuit and the Arduino. Okay, but pay attention about this. You should not use the hardware UART on Arduino because this is, you see, this is the hardware UART pins, the pins 1 and pin 0. Two pins TX and RX right here is connected to the computer to uploading code. So if you connect your module SIM to these two pins, the Arduino will be completed when we uploading code to Arduino. So, but if you still want to use these pins, I have a solution is you have to remove the wire out before uploading code. Okay, just removing, and then after uploading code you plug into again. But it's quite inconvenient if we connect the module SIM to the big circuit, right? You cannot plug plug and remove anytime. Okay, and the solution is we will use software UART. On Arduino, we can use this library to set up all pins on Arduino to a UART. Okay, we have to include software 0.h. We don't need to download this library on the internet because it's already in your library when you download the Arduino. Okay. Okay, and next this is how we initialize the software UART with the name you want of this, and we'll rename it in mysoft UART. And this is a two parameter. The first parameter I will set up for the RX pins, and the last one is TX pins. Okay, in this video I will use the pin 3 for RX and pin 2 for TX. Okay, remember that. And this is the function begin. Okay, do you remember begin in the 0.begin? Okay, with the software UART, we can use all the function as the hardware UART, so we don't have to worry about that. And the module SIM use the baud rate 115200, so we have to use the 115200 to communicate with the module SIM. But with the serial monitor on Arduino, we still use the baud rate 9600. Okay, remember that. Okay, and the last one is the diagram. With the module sim, it needs a high current to operate. So I have to connect to the capacitor with a 2200 UF, and the voltage right here. You can use any voltage you want. Okay, and just connect it to the 5 voltage and the cathode pin to the GND. Okay, and GND of module sim to GND of Arduino. The 5 voltage of Arduino is connected to VCC of module sim. And right here I have 3 buttons. The first is connect to pin 12, the second is pin 11, and the last one is pin 10. Okay, and 3 of these pins we use to test the module sim. The second is it will make a call to the phone, and the last one will send a message. Okay, as I said, I use the pin 3, right? Pin 3 for RX and pin 2 for TX. So I have to connect RX of Arduino to the TX of module sim, and I have to connect the RX of module sim to the TX, because if you want to transmit to module sim, I have to send the data from the TX pin to the RX pin. Okay, and if you want to receive any data from the module sim, you have to connect the RX pin of Arduino to TX pin of module sim. Okay, can you get it? Okay, this is a module sim, right? And this is my sim. Okay, and I have to plug with this size here. Okay, just push it into the module sim, and right here I have a capacitor, and I stick it in the module sim for easy to use. Okay, and this is the circuit. I have already connected some wire to Arduino as the diagram. So I just plug the module sim into the dashboard and then uploading code. Okay, I will show you the code before I upload. Okay, and this is the antenna. It's the antenna of NRF. Okay. Okay, now we connect to the dashboard. Okay. And this is a phone I will use to call or receive message from module sim. Okay. Okay, and this is the code. First, I have to include the software serial library, and then I will edit it to my software URL with the pin 3E RX and 2E TX as I said. I will create a combine string to combine one by one data from module sim to compare, to check. Okay, to check it. And this is the index to count. This is a chair receive. I will assign the my soft URL.read to this chair. Okay, to keep the data to avoid lost. Okay, and this is the get response function. It will receive data from module by this function. Okay, and I will set up 3 button as I said, input, and I will use the input with internal resistor. Okay, input pull up at pin 10, 11, and 12. 13, I will set it to output to blink when receiving call, and set the mysoft UR dot begin 115200 and the serial dot begin to communicate with serial monitor at 9600 baud rate. Okay, in the develop function, I have two, three, four, five, about 5 functions. The first one is here. If my soft UART not available, it means if you receive anything from from module sim, I will get that data to receive and then compare it with the character I have right here. Combine with ring, that means I will combine with ring. So I combine ring because if I receive a call from mobile phone, the module sim will send to the Arduino a string that is ring, okay, and but it will send one by one. So the algorithm below, I combine one by one data and then compare with the string we want to compare, that is the ring. Okay, right here I combine. Okay, right here, if the data I receive or I will increase the count and then combine it. That's it. After combine, I get or, and just like that, I can get rin, and ring, and then I will compare it with ring. If it equal, at the same time, if the index is 4, I will blink default LED to um, mention to the user is have someone is calling to you, okay, and then I will reset the combine string and reset the count. And with the K right here, I will detect noise because because sometimes I cannot get the ring, but I could get some special char because it's quite noise. So this function will detect noise and then reset the combine string, okay, and reset the index to ready to get a new data, okay, and then I will bring the receive to the serial monitor, but the receive here is can be some data like no career or anything the sim send to the Arduino, it's just not ring, okay. If I press the button 10, I will send to the AT command to module sim to test. And with the 11, if I press the 11, I will call to my phone. The ATD is the command and the XXX right here is your phone number, okay. And the last one is procedure to send a message to the phone, okay, and this is the end notation. Okay, we connect my Arduino to the computer and see what's happened. Okay, let's connect. Okay, now I will connect. Oh, now I will upload it and open the serial monitor. Okay, the open serial monitor right here. Now I will test to module sim. That's okay with AT command. I will press the button 10 on the left. Okay, on the left. I will press it. Okay, AT okay. AT okay mean your module sim is work good. Okay, that's again. Okay, okay. Now I will make a sample to call to mobile phone. This is the pin 11. I will press it and it will call to the mobile phone. Let's see. Oh, sorry, I forgot to put the number right here. Okay, I will put my number. and I also put the number right here. Okay, let's upload again. Okay, let's check. First, 80, okay. Okay. And now with the mid button, press. Okay, it's calling my phone. Okay, you see? Okay. And you see when I not answer, it will display here busy. Okay, and if the module SIM cannot call to the mobile phone, it will display error, or I don't catch the phone, the monitor will bring no carrier. Okay, you can test it by yourself. Okay, now I will try to call from this to SIM. Okay, let's check. Okay, you can see it ring. It's display ring right here. At the same time, the LED 13 is blink. Okay, you can see it. You can see it blinking. Okay, no carrier. And now I will send some text from module SIM to the phone. Okay, let's check. I will press this. Welcome to Programming Knowledge. Okay. Okay, here. Welcome to Programming Knowledge. Okay. It's easy, right? Okay, and now I will try to send from message from phone to SIM. Okay, let's check. Okay, let's check the monitor. Okay, here it receive okay hello. Okay, that's it, all the application with the module SIM. You can find out more in this link. I will put it in below the video. It will show you more tutorial of module SIM. Okay, and it have a sample code right here, and it have more 80 command you can research. Okay, thanks for watching. Welcome to Programming Knowledge. Today I'm going to talk about Bluetooth topic. Okay, let's go. This is the modules that we use in this video. The name is HC05. Out there has a module is HC06. But actually there's a manufacturer and I will work with HC05 in this video. Okay, right here you see this is the button on the modules. That is the button to reset or program the module, and the program right here will help you change your name and password, change the baud rate, or reconfigure the HC05. Okay, next, this is how we access to the program of Bluetooth. Okay, first we have to unsupply the voltage and then press the button and then we resupply the voltage. and still hold the button until the LED of the module is blinking slowly. Okay, that's how we access to the program mode. Okay, and after we access to the program mode, we will open the Arduino IDE and open the serial monitor. With the Arduino IDE, we have to upload the empty code to the Arduino like this, and then open the serial monitor to set up the information like this. We will select the both NL and CR. That's the slash R and slash N. Okay, and the next is the baud rate. We have to set to the 3A400 baud rate to communicate with the Bluetooth. Okay, and this is some command to program the Bluetooth. First is AT. This means it will help you test the Bluetooth. When I send the AT command to the Bluetooth, it will respond for the first time is error 0, and for the second or the other time, it will respond the OK. Okay, and next is AT plus PSWD question. It means we can check the current password of modules, and then we send this command, it will respond the current password of Bluetooth modules. Okay, and this command AT plus PSWD is 1234. It will help us set the new password, and that is the 1234. After we send this command, the Bluetooth will respond OK. That means you changed your password. Okay, and the last one is AT plus name is hello. This is will help you set the new Bluetooth name is hello, and the response right here will respond the OK. Okay, this is error. Don't. It's not respond the current name, but it's respond the OK. Okay. Okay, and this is a diagram to program the Bluetooth 5 voltage to 5 voltage, GND to GND, and RX of Bluetooth will be connected to RX of Arduino, and TX of Bluetooth will be connected to TX of Arduino. Pay attention about this, okay? Pay attention. RX to RX and TX to TX, okay? Okay, this is my circuit, and this is my Bluetooth. Okay, it also have 5 voltage GND, TX, and RX. Okay, and I will use the test board to plug the Bluetooth into for more stable. Okay, let's connect. First is 5 voltage for the red wire. GND, I will use the blue wire. And the RX, I will use green wire as the diagram. Oh, let's check the TX again. Okay, the RX. Alright, so I wrong. I will connect the RX to RX. This is TX, and the last one is RX. Okay. Okay. Now we'll connect the Arduino to my laptop and then upload the empty code. Okay, you see. Now I will press the button to access to the program mode. First, we have to unplug the supply voltage, and then press still hold and resupply. Okay, you see, the LED is blinking very slowly, so that means you access the program mode. Okay, now I will open the empty project and then upload it to the Arduino. Okay, done. Now I will open the server monitor. Right here, I will, oh, right here, I will change to both NL and CR. Change to 3A400 bar rate. And now, first, I will send to 80 to check my Bluetooth. Then, okay, for the first time, it will respond error 0. And for the second, it will respond okay. Okay. And we have to check the current password by 80 plus P SWD question 10. Okay, the default password of module is usually is 000 and 0. Okay, and now we will check the default name of Bluetooth. We cannot use the command, okay, and now we will use the phone to check it. Right here, I'll use Bluetooth setting Bluetooth. Okay, right here, that is SC05. The default name of Bluetooth is usually SC05. Now I will try to connect it. And the password. Oh, because I am in the program mode, so that is why I cannot connect to the SC05. Now I will try to change the name of it. 80 plus name is now change to program knowledge PKNL programming knowledge. Okay, PMKL. Okay, let's send it. It's respond okay. That's the we can change the name of it, and we will change the password to 80 plus PSWD is 1234. Then okay, and now the password and the name is already changed. Okay, you will see the SC05 right here, but I will reset the module. You will see it will change to the PMKL. Okay. Unblock again. And now I will turn off the Bluetooth and turn it on again. Yeah, I'm sorry. Okay, right here you can see it, SC05. But it's still SC05, right? Okay, let's reset. Oh, I don't know why. Okay, let's check it again. But the password is changed, but I don't know the name it doesn't change. Okay, let's check again. Okay, let's send again. 80 plus name is P programming knowledge. Send. Okay, send for second time to name is PMKL. I will send the second time for short. Then, okay, now check the password again. Okay, still 1234. Okay, now I will reset the Arduino. Okay, let's lock it down and unlock again. right here. Oh my god. Also, so don't worry about the name. Just connect and check the password. 1 2 3 4. Okay. Oh, right here is changed when I connect it. Okay. Okay, and PMKL. And after I connect the Bluetooth, the LED right here is blinking slowly. Okay, you can see it. Okay, now for the next, I will, after we change the name and password, I also have application to control LED via Bluetooth from the mobile phone. Okay. Okay, I will use this application to send data via Bluetooth. You can use the other application which can send the data via Bluetooth. Okay, but I will use the Bluetooth terminal HC05 of this. And pay attention, the HC05 is cannot connect to the iPhone, so we cannot use the iPhone to communicate with the Bluetooth. Okay. After I download this, I will open it and connect to the Bluetooth. Okay, and the diagram with the Bluetooth right here, I'll use the software UART pins ERX E2 and TX3. I will connect the RX2 3 and TX2 2. Okay, I don't use the hardware UART because it will conflict when uploading code or do something with the hardware UART. Okay, I told you as the previous video. Okay. Okay, this is my circuit and I will change the RX2 TX and TX2 RX with the previous circuit. Okay, now, but this is the hardware UART. But as I told you, we have to change to the software UART. And my software UART with the RX pins, I will use pin 2. Okay, pin 2. And the TX pin 3. Okay, right here. The RX is the brown one. I will connect to 2 with TX. Oh, sorry. Change it again. Okay. The here this is RX2 3 TX. Okay. RX to TX and TX RX. Okay. I have already downloaded the application. Here it will ask me access to the Bluetooth. Yes. Okay. This is the PMKL. Okay. I will pair. Okay, pair it, and there's something wrong. Okay, so don't worry about that. Now I will uploading code to read down the text from this phone. Okay, I have some code right here. I will include the software UART with the RXE2 and TE3. I will use the serial of UART E9600 barre with the software UART. I will use 96002. Okay, right here, if I receive anything from mobile phone, that means when I receive anything from Bluetooth, it will run into this if condition and bring out that data to the serial monitor of your Arduino IDE. Okay, let's upload. Okay, with the software UART, we don't need to log out this. Okay, we just upload as we want. We don't need to disconnect the wire of Bluetooth. Okay, done uploading. Now open the serial monitor, change it to new line, change it to 9660. And now I will send something A, B, C. Send ASCII. Okay, try here. This will receive A, B, C, /R and /N. Okay, now I will print it as a char. Okay, I will create a char. Data is my UART.read and print data out. Okay, print data out with the no new line. Okay, let's check. Okay, I will send hello. Then, oh sorry, I don't. Here, hello. Programming knowledge. Okay, then. Okay, programming knowledge. Okay, that's how we send from mobile phone to UART. And now we will send back. Okay, we send back. We have ABC. Send. Okay, I cannot see anything. Okay, and now we will change to okay. I will send it back with 5 seconds per 5 seconds. We send it back. Serial. Oh, sorry. My UR dot print hello from Arduino and delay 5 seconds. Okay, uploading code and let's check. Yeah, see, hello from Arduino. Hello from Arduino. It will send after 5 seconds. Okay. Okay, that's how we communicate with the Bluetooth and mobile phone. Now I will give you an application to open LED. Open the default LED. That's the pin 13 to blink or do something with the control from mobile phone. Okay, let's check. Right here, I will set up the LED. Pin mode 13 is output. And if I receive the letter A, I will turn on the default LED. And if I receive the letter B, I will turn it off. Okay, right here. If my mark not available, share data here. If data is A, I will turn the LED on. Digital rate 13 high. If not, if data is B, I will turn it off. Digital rate 13 low. Okay, let's check. I will comment it. Okay, let's check. Uploading code. Okay, now I will send the letter A. Then, okay, you see it? It's on, right? The default LED is on, and now I will turn it off with the letter B. Okay, that's how we communicate with the mobile phone. Okay, this is a useful application, right? Thanks for watching the video.